Hello, I'm MC Toon, the worst rapper in the world. How you doing today? Today we've got a special one. We've got a debate with Spurskimo, and he's connecting right now, trying to get the audio going. So it looks like he isn't yet connected, which is that's fine. We'll give him a chance to connect. I don't hear him, but we'll see. We'll see if it works for him. I've got a few things to go over later on tonight in 4 hours time. I've got former 5G cell phone tower installer Ian Ferguson. He's done a couple videos talking about what he thinks is bad about 5G. And let's see, Spurs is asking, do you hear me? I don't hear you yet. So so Ian will be on. I will also have Jon Snow with me at the time. So Jon Snow is also mostly kind of sort of against 5G. We'll see if we can have a productive conversation about it. This is it's not meant to be a debate, meant to be maybe educational and maybe entertaining. We'll see. Then later, after that, we've got, based on suggestion from Gary Stewart, going to do a stump tune. So it'll be a chance for people to ask a question of me, science specifically, if you can, on 5G or flat Earth stuff, or just Earth shape, not flat Earth because it's not flat, but Earth science type things. I'll do my best. I don't know. We'll see how that goes. That should be good. So if you're interested if you have a question or anything, then it'll be on Zoom. So install Zoom, and I'll put a link. We'll have Vishanti's going to help out in the Discord server. So yeah. Anyway, so yeah, Spurs or Chemo. He's having Spurs Chemo, like people call him both. So yeah, I cannot hear him. Let's see. Yeah. So if you hear me, Spurs, I don't hear you at all. So something is up with your microphone. You're not muted or anything. And I see there's like a little indicator on whether or not you're talking. So Zoom is not hearing you speak. So there's something about your microphone that's not quite working right. So I don't know. Yeah, you're not muted. So we could try, well, if you're not going to be on screen, we could just do Discord. What about that, Spurs? What do you think? We can do a Discord call because we're both on Discord. So let's do that. So you can just drop out of that, drop out of Zoom, close that down, and I will give you a ring on Discord. There it goes. I'm figuring he probably has Discord working better. So let's see. Observer says the ultimate stream would be to have MC Toon moderate a debate between two flat earthers that don't agree with each other. I actually offered to do that with Nathan Thompson and Flat Earth Millionaire, because Nathan thinks there's a dome and Flat Earth Millionaire doesn't. So now let's see here. I still don't hear, but maybe that's my settings here. Just a second. I still am not hearing. That's it there. We got to go switch it to this. All right. Chemo, can you say something?
Hello.
Oh, people hear you, but I don't.
Hello.
Wacky.
Hello.
That's just wacky.
Good evening. Do you hear me?
I can fix that. So I guess you could say whatever you want right now. Don't. I'm kidding. Because I can't hear you. So let's see. That's not it.
See, it's not me. I think my Zoom was probably working just fine.
Somebody.
Possibly it's on your end, McToon. Your settings
this
possibly.
Is connected. My earbuds are connected. And
I don't know if you're new to this flat Earth, global Earth discussion where people use technology devices to talk to one another. So
I will
just
disconnect my Bluetooth and reboot the whole
you need to unmute me.
Bluetooth system. So could be very possible that that's my fault. So redoing it. Power off. Power on.
Yes, you see. Do you hear me now?
Connected to
Two?
Bluetooth. Okay.
Any joy? Chance?
Oh, I hear you now.
Yeah, you can hear me. Hello. Good evening.
Excellent. Sorry about that. Yeah, that was something on my side. So.
Yeah, I mean, I think in Zoom possibly was working as well. I think it was your end.
Yep.
Not to worry.
Definitely is a possibility. So, all right. Well, I'm glad to have you on. And people at home, are you hearing him loud enough? Is the question. So we'll see how they respond. So now, is it okay if I switch between calling you Spurs and Chemo, or do you have a strong preference?
Yeah, I mean, some people wonder, is Spurs Chemo? Is Chemo Spurs? Whatever you take, whatever you fancy.
All right. I think I've called you Spurs in my head more than Chemo. So
sure.
Mute Donkey says you're too loud. I think he wants you muted. So
already
there's that. Yeah. Already. They're saying you are a little too loud. All right, I turned you down a little. Okay, so welcome. Glad to have you. I was challenged by Fight the Flat Earth by Craig to have you come on, and so I'm like, oh, fine. Right. So my first question now here's the deal. Whenever I have somebody come on, often I get people saying, why are you platforming this guy, and this guy's a Poe and all this. But here's the deal. A lot of people contacted me this time, a lot more than ever before, saying he's a Poe. You know what Poe is?
I think it's someone who doesn't actually believe in something or something like that.
True. Yeah. So the idea is that they're saying that you do not actually believe that the Earth is flat. So my first question then is, do you actually believe that the Earth is flat?
It's not about what I believe. It's about what we can demonstrate. I mean, if you want to talk about what I believe, we can get into all kind of religious discussions, philosophy, and that kind of nature. But when we talk about what we know, we know for sure Earth is absolutely flat. Yeah.
When you say we, now I'm not included in that we, but okay, I'll take that. So then I'll ask you, I got 5 questions, yes or no on these. We'll go through and then we can wrap back around if you want. But if you could just give a yes, no, and then we can expand on any of them that you want after. So first one, do you have a 2-scale map of the Earth useful for international navigation that works as well as the globe ones that are currently used for navigation?
Do I have one? No.
No. Okay. Do you have measurements of flatness with units?
When you say measurements of flatness, what do you mean? What do you mean by that?
Just a second. I'll ask the whole thing. Measurements of flatness with units, significant digits, and a margin of error analysis. So flatness would be, somebody says water is flat, then that would be a claim based on measurements. So do you have measurements of the flatness of water?
Based on measurement, but that's what I'm asking. What would that measurement look like? What would the number be?
Number
compared to what? Compared to what?
It could be something like at half a mile out, the surface of the water has deviated a certain amount, and the margin of error analysis is this, right? And the
I don't know. I'm quite sorry. So, are you talking about like if there's a wave? Are we talking about like a lake, a pond?
Yeah.
Are you saying
ideally well, because margin of error matters, right? If it's the ocean and you're 100 miles out, then the margin of error is much larger potentially than if it's on a pond and or a small protected lake.
When you say error, what are you comparing it to?
Well, every measurement has a margin of error.
No, but hold on, look. You're saying if something is flat, it should give a measurement,
yes,
like a number, yeah?
Yeah.
So what would that number be?
Well, I was saying, so you could say, well, we measured that at 1 mile from this point to this point, at 1 mile out or half a mile out, the surface of the water has deviated or not deviated from flat by a certain amount of inches, meters, millimeters, whatever. And then here's...
All right, so look, let's start small. So you're in your kitchen, take a cup of water, pour it on the floor. Are you saying that is curving or that's not flat?
I'm just asking if you have measurements, right? And so, like,
No,
I don't want to expand on it,
like I said,
right now.
Because, like I said, if I pour water on the floor, like a glass of water, and then it levels out, lays out flat, what number should I give you in this moment to tell you that water on the floor, on the kitchen floor, is flat? What number would you be looking for?
Well, you could measure it in degrees of curvature, or right, and you would be looking for 0.
I don't know. That's what I'm asking for.
Yeah.
I'm saying to you,
that's what I just told you.
So degrees. So you think that water on the floor, on the kitchen floor, has a degree of curvature?
Well, that's the question. That's what I'm asking. Do you have measurements that over a significant distance that the surface of water is flat or not? Do you have measurements? It's just we can come back and expand on it, but I'm just curious if you have measurements.
A measurement? No measurement.
Okay. So then, similar question. Do you have a measurement of stationariness, again with unit significant digits and a margin of error analysis?
A measurement of motion.
I like to say stationaryless because I love making up new words.
Stationary.
Yes. Or
a measurement.
Yeah, non-movement. Yeah. Something that is designed to measure movement that has that
So
confirmed.
If it wasn't moving, if something wasn't moving, you would get what number do you think you would
Well, I would figure the number you'd want is 0. 0 miles per hour, 0 meters per second, 0 degrees per hour, 0 something, right? Do you have measurements of that?
No.
Okay. We're almost there. Do you know the elevation of the sun and moon over flat Earth?
I haven't measured it, no.
No, okay. I have. And then do you have a predictive hypothesis for the downward acceleration of about 9.8 meters per second squared, and also that accounts for the slight variation in this amount all over the Earth?
Okay, again, so when you say downward acceleration,
yeah,
are you invoking a force is causing this acceleration?
I'm just saying, if you drop something, there's an acceleration. We can measure that acceleration. We know that it's about 9.8 meters per second squared all over the Earth, but it varies by some small amounts.
Okay, we can talk about that. Possibly, maybe there's a hypothesis for it. Yes, we'll talk about
possibly, maybe. All right. Well, based on that, because we have all of those for the globe and more, on my website, mc2.net/burden covers pretty much all of those. Burden, as in burden of proof, has been provided, right? So all of those things and more. So kind of you already lost, but that's fine. We can still have a lively, a lively chat here. Have some little banter about it. So
sure.
So
look, let's go back a little bit throughout history. So obviously they used to think the Earth was flat back in the ancient world.
Yeah, they got
and then some guy came up with the idea that the Earth may or may not be a ball. So obviously he wrote down on a piece of paper. He's came up with a presupposed number. He's built a model based off that, and over the 500 years, that model has been corrected over the time. You had the sun at 1 million miles away. You had a different size of the sun until today. The model's finally complete. Well, up until Einstein, because before you had Newtonian gravity, yes, and then we understood that's not a force anymore, which was superseded by Einsteinian gravity, which is the bending of space-time.
It wasn't actually superseded.
What do you mean it wasn't superseded?
Well, nobody claims that it superseded Newton. It's an expansion of Newtonian gravity. That's, in fact, Einstein himself said he didn't at all accept that it was a superseding of it, that it was just an expansion of it. In fact, everything that Einstein posited supported Newtonian understanding of gravity. So I'm just a little correction on that.
Yeah. I mean, like, I've got a problem with that because remember, this was just an idea from the old world when they used to think it was flat. And remember, some guys, a guy or a girl or someone came along and said, "Hey, I think this could be a ball." And again, they wrote down some equations to figure out a model for a globe. And remember, no one actually went out there and measured the actual curvature of the Earth. No one's been around the ball. No one's actually tested this. Now, obviously, like I say,
people did. It doesn't. I don't care.
Let me speak a little bit. So
that's fine. But
obviously,
people did measure.
Let me speak a little bit though. Then you can. I let you get your 5 points out.
Okay.
Let me have my little bit of time to say how I see it. Then you can correct me.
Sure.
Okay. So over that 500 years, like I say, things were being corrected. This idea, because with any good idea, you need solutions to improve upon that idea. So that globe idea needed other ideas. So the idea was, well, how do you explain water sticking to the board? Someone came along and said, "Hey, got an idea, gravity. Let's say there's a force pulling the water to the center of mass." And then obviously Einstein came along with a better idea and said, "Look, it's not mass attracting mass anymore. The idea is today that we have the bending of space-time." Okay? So again, the ideas will continue because that's how your worldview works. Science develops and continues until a better idea or an equation to fit your model comes along. Over to you.
So, yeah, it didn't say that mass doesn't attract mass. That's not what Einstein said. He gave a further explanation of it, but mass still attracts mass.
So that's the idea, right. McToon. Yeah. The idea is that to explain why water sticks to the surface or is pulled, it needs a force, yes?
Yeah.
But then obviously, like I say, Einstein came along with a better idea, okay, a better equation that explains the bending of space-time.
Yes.
See?
Yeah.
So obviously, what we had, was a physical attraction, a force, mass attracting mass with Newtonian gravity. And then that idea was replaced now.
Not replaced, enhanced. I'm
sure you're familiar with the old trampoline. You put a ball in the middle of the trampoline, yeah?
Yeah, I've seen that.
And the balls are attracted to the balls roll to that other ball, yeah?
Yeah.
So we know that in the ball that's in the center, there are no attractive properties in that ball
that's just a visualization. So here's a question.
Hold on. It's not just a visualization. This is what's happening. You're bending the fabric around you, causing the other object to move towards the other object. Now remember, the ball that's in the middle has no attractive properties. Not like a magnet, because unless it bends the space around it, the other object does not move towards it. Do you understand?
Yeah, that's just meant to be something for people to visualize how it works. That's not.
Well, that's exactly how it works. Space is a fabric where the larger mass.
I don't think that you really are in a place to be telling people what they think about stuff like that, right? That I think it's basically. It sounds like it's more of a misunderstanding on your part.
Possibly, but like I say, unless you can show mass attracted mass. With all the variables accounted for example, Cavendish. Cavendish would need to be shown in a vacuum where the atmosphere is not affecting the objects because the cause of those objects could be numerous.
Sure, as I said, I've already done all this. So on my website, mc2.net/burden, or you can jump straight to it, mc2.net/g.
Sure.
And I will pull that up right now. So what I'll do is I'm going to share. Oh no, I can't share. You're going to have to look on the stream. I'm not on Zoom, so I can't share.
Yeah, I can see it. I'm watching.
Okay. So I will, right there, that's my website. My black swans all the way down there. Look at that. Flat Earth is black swans all the way down. So here is 16 measurements of the strength of gravity. So in here are several different experiments described. And the majority of them are in a vacuum. So this particular one right here at the top, measurement of Newton's constant using a torsion balance with angular acceleration feedback from 2000, that is in a vacuum. In a vacuum
Now,
chamber.
look, remember, this is an idea, McToon, that people have to support their claim, okay? So what you have here is something written down on paper. As I told you initially, the first person who came up with the globe wrote down, they didn't actually do a practical demonstration that we all could see. Now, what you're showing me is a picture of mass attracting mass. This is not science, McToon. You would have to show physically, objects moving
Do you think
towards
that
one
all
another in a
science
vacuum.
has to be on YouTube?
No, you would have to show, you'd have to record it, put it somewhere where others can see this phenomenon of mass attracting mass.
That's not actually how the scientific community does things.
I know. That's what I was saying to you. I said to you originally.
None of us in the scientific community give a damn about your opinion about how it is done. If you don't like it,
you're being very aggressive now, McToon. I did say to you initially, this is how your science is done. Somebody thinks of an idea, they write it down like you've just done now.
Yep.
You write it down. You don't show the practical demonstration, and then somebody may come up with a better idea or another idea.
Yeah.
But nothing will ever be shown to support your idea other than what you've written down.
But here's the beauty of how the current science community does things. Somebody publishes something, right? Mm-hmm. And there's an invitation that comes with it to prove them wrong, to show that they're wrong. So if you wanted to disprove this this experiment by Jens Gundlach and Stefan Merkowitz, there's an invitation to you to do it, to set it up your way, to do something similar, to find what's going on and see if there's an error in what they did and prove them wrong. And here's the cool thing: you get all the street cred that they used to have, man. And you
but
would
that's not how science in the real world works, because what we're looking for, McToon, is natural phenomenon in the physical world. So we would, as humans, scientists, people in general, anyone, we would have to see something in nature, and we would have to question that thing. We would say, "Hey,
mass attracting mass.
How do we explain that? What is our hypothesis for what we can see?" Now, we can't see anything other than a guy that you say has written something down. There's no phenomenon here. There's nothing here to investigate.
The phenomenon is mass attracting mass.
Again, that's your words written down. There is no observed phenomenon here, McToon. So therefore, there is no need for science. What you do need is mathematics
of the torsion bar.
Yeah, what you'll need in this case is mathematics to make equations to fit the model. But if you want to show practically that mass attracts mass, it's not just an idea. Obviously, you would have to show this natural phenomena in nature.
And it's happened, right in this one.
I hear what you're saying. I know what you're saying. You're saying that on this piece of paper, we can see the natural phenomenon, yes?
That the current scientific community doesn't publish their work on YouTube.
Sure.
Right.
But what we're trying to see is the natural phenomenon in nature, McToon.
That's the attraction between masses,
and then that natural phenomenon in nature?
And then the twisting in their experiment, it was observed by the experimenters.
Where can me and you, McToon, see this natural phenomenon?
You could build your own torsion bar experiment and see if it works yourself.
So we can't see it then, McToon. At this point, me and you have never ever seen.
Absolutely, you can go do that.
Right now,
feel free to build your own torsion bar.
But we could never show anyone other than our ideas of mass attracting mass. Is that what you're saying?
I think you quite misunderstand how science is done.
Well, again, how it should be done is you have a natural phenomenon which would be questionable.
Mass attracting mass.
You'd form a hypothesis, McToon, and that would be your predictive cause to the effect.
So the hypothesis
McToon,
is.
You don't even let me speak, McToon.
Well,
you're asking me to do something. You're asking me to repeat something that I haven't seen.
It doesn't matter if you've seen it or not. I don't care if you've seen it. The current science doesn't give a damn about your opinions about how science should or should not be done. You're just, some guy that doesn't like how science is done. So go ahead and create your own branch of something, call it something other than science, and see if you can actually, explain things with it. See if it gets explanatory power, because that's the beauty of science.
You're getting quite flustered, and I haven't hand-wave dismissed your experiment. I'm saying if mass attracts mass, we should be able to see that. I did say to you originally that the idea of a globe was just an idea. Someone wrote it down, never actually measured it. Then the idea of gravity had to explain how water and objects stick to the surface. Again, today, 2020, you have the same idea. You've written it down and said, yeah, that's the idea, accept this as science.
Yes, absolutely. That's how science is done. Yeah. Somebody does an experiment, writes it up, and then publishes it. And then other people review it and say, you know what, I think you got it wrong here. Let me, nitpick on that. Or it looks right. You did this. If you did in fact do the experiment as you explained, right, then this, that all works. If your measurements are right, then your math is correct. Your hypothesis is confirmed. And that either confirms other existing science or it contradicts existing science. And that's a big deal. And it's celebrated. Like, if somebody were to be able to disprove some well-established science, that's a Nobel Prize right there. They pay well for that.
But this is why we say you have a religious belief. Again, this is not at all religious.
It's in fact the opposite of religious. It's specifically
how so? Show me the difference between religion and your science. What's the difference? So, and give me an example, like give me a demonstration of the actual difference.
Yeah, so the difference would be that somebody does something and it's never been done before, and people are like, I don't know about that.
Like a miracle. Let's say miracle healing. Yeah?
No, that's not what science is studying.
No, let's say somebody claims there's a miracle heal, and then thousands of people around the world agree, witness it, repeat it, then what? What's the difference between what you say and let's say someone just wrote it down that they did a miracle healing, and then someone else did a miracle healing and then wrote it down, but you never saw this miracle healing.
Yeah, so
would you accept it?
I would say let's test it. What's the hypothesis? The hypothesis is that.
So that's what I'm asking you. So why would I ask you about your hypothesis? You don't follow the same line of thought.
Well, of course, you didn't let me ask the hypothesis here. Right.
Okay.
If this guy, some guy can do miracle healing, right?
Yeah.
Then he will be presented with somebody who has been confirmed independently to have some condition. And then
by who? Who's the authority? Because like I say, you can have thousands of religious people,
experts. Somebody.
I believe that. I saw it. I repeated it.
Yes.
Then what?
So let me finish. Right. So you confirm to people's satisfaction that somebody is not healthy, right? So maybe they're missing a leg, and you'd go and look. Sure. Yep, no leg there. Then you'd bring it to this miracle healer, right? And you'd say, all right, here's a guy, no leg. Go ahead.
No, not that kind of healing. Don't be silly. We're talking about someone maybe who has like a sickness. Yes?
Well, why not a leg?
Because people don't grow legs back, do they?
Well, I've heard people claim that.
We're not X-Men, are we? Now you're talking about some kind of fantasy here. Come on, let's get real.
I don't know.
You can't show any difference between your science and religion. Because what you've just said...
it's testable. As long as it's testable, then we can explore it with science.
Where are the tests then? If it's different, if you're not religious, where are your practical demonstrations? Practical. Not pieces of paper like the Bible. Practical. Where are they? If you're not religious.
They write them up, right?
So do the people who write the Bible. The religious people write them up. Same as your religion. Where is your practical demonstration?
Yeah, that's the point of it. It's if somebody doesn't like it, then they can go test it themselves and find if it's correct or not.
And so religious people do it all the time. They go to church every single day. They pray to God every single day because they find out that what other priests say and religious people say are true. You're saying that there's a difference because you have practical demonstration, but you're yet to show a practical demonstrations to highlight the difference.
It's right on the screen there, actually.
That's a piece of paper. Remember,
it's testable. It's actually a PDF, but it's testable, and that's the thing. Like I said, with the miracle healer,
I know.
So,
with miracles,
you look after
you all day long.
You look after the test, and you find out did the leg then appear? Does he now have a leg?
That is being silly, McToon. You're being so silly. A leg. How can we grow a leg back?
Well, I don't know. You're talking about miracles, so it doesn't really matter whether.
Yeah. So if you have a sickness,
what's a sickness?
I don't know, cancer or something,
Cancer. Okay.
or like.
Okay, perfect. Cancer's better. Fine. So we go beforehand and you take an X-ray and you find, oh look, we have right there this type of cancer. You have a medical doctor. You have multiple experts that have experience in this. They look at that and they say, yes, cancer. You bring him to the guy. He does what he does.
Healer.
Then you go afterwards and you repeat the same test to see if he still has cancer. If the cancer's gone, then miracle healer confirmed.
Right. So we know today there are people who go and see miracle healers. So obviously it works, right, McToon? Otherwise, if it didn't work, people wouldn't
obviously it works.
Right, so let's not talk about religion. Let's get back to the science, McToon. Let's not bash religion. Otherwise, we're bashing your own religion.
That was you.
Let's talk about your practical demonstration. Let's see the separation between your science. Let's see the difference between your science and religion. Let's have a look at something today, practically.
So, in a religion, it's not generally testable. So, the miracle healer isn't. That's actually testable, right? But the religion being, if you believe this, then when you die, this will happen. That's not testable, right?
Okay.
So that's religion, where science is
that's faith. That's faith, yeah.
Yeah, absolutely.
So people would have faith in it, yes.
Yeah. So here's the deal: if you take this bar here, right, and you suspend it from a wire, and you have a mass on either of these sides, and you let it find equilibrium, then you introduce a mass here and a mass here, right? Then that bar will twist or not based on the hypothesis, right?
McToon, can I just stop? I know the model. I understand what's supposed to happen.
So have you seen that falsified?
I could explain to you the Bible all day long, but it's pointless, okay? Because you would say, demonstrate it. You would be demanding a demonstration of something from the Bible.
No, I wouldn't.
So I'm asking you the same thing.
But
can you, instead of presenting me a paper, can you practically demonstrate that mass attracts mass?
I could if I built my own torsion bar, and so could you.
I could do miracles if I tried, and so could you.
I could not. You think I could do miracles? Thank you very much. I appreciate your vote of confidence, but
no, but the point is, I'm making a point, is that this is how silly this has become, because I'm trying to show you that your religion and religion are identical unless one of them have a practical demonstration to show
it's about
that one of them
It's not about practical demonstration. It's that the key about science is testability.
What are you testing? We
could test whether or not when a mass is introduced in the correct spot of the torsion bar, whether or not it twists when that mass is introduced. That's the test right there. Does mass attract mass? Introduce the mass.
The cause to this effect.
What's that?
You know the cause.
That would be mass attracting mass.
Because listen, let's say a monkey built that device, somehow put it together.
Okay.
Whatever effect happens would have been because of what the monkey did, McToon. You not get it? This is not a natural phenomena in nature. We want to see things in nature.
I'm sorry.
Untouched by man.
I think you get confused about how science tests nature and the word nature that science talks about.
Is that an ad hom? I don't understand. What I don't know. I'm asking you for a practical demonstration. Yeah, so I can understand that you understand what you're talking about.
Yeah. So if you doubt that these papers are correct, if you think that they're wrong and that people are lying about it, you can get yourself $1 million prize by disproving them. Go ahead. The invitation is open.
Why are you turning this around to me? You're the one that is making the claim, so you're the one that should have to prove it.
Yeah, and this is how science works. Somebody does it, somebody writes it up, somebody communicates it, right? So if you look at the scientific process, one of the last steps, depending, there's a bunch of different scientific method lists, right? But in general, one of the final steps is report your results. And that's how it's done. It's done today
What you're
in
saying, Muktu,
journals,
the way
typically.
science works is exactly the same way that religion works. Right now,
No,
today,
religion
here
is
and
not
now,
testable.
there was no different. We haven't tested anything, Muktu. What have we tested?
I already went over that.
Nothing.
Whether mass attracts mass. When you introduce a mass, does it
We
cause
talked about it.
Does it cause a
We
twist?
spoke about it.
Yeah, yeah. All right.
We
So
could talk
let me.
about religion.
We got a couple questions here. Swedish Vapor UK is wondering how big is the cup and/or his kitchen floor?
Just like a regular coffee cup size.
Okay.
Coffee cup. I don't know how big they are in America. Just a regular standard cup. But the point of that question, let's go back to that point. Yes. The point of that question is you pour the water onto your kitchen floor, and what you're saying, Kuhn, is that water will be higher in the middle than towards the sides of the water.
If the Earth is a sphere, it certainly would, and it would. The margin of error is the challenge there, of course, in the quality of the measurement. Are you Scottish?
It's not about me.
No, I'm just wondering. Are you Scottish?
It's really not about me, Muktu.
I'm not Scottish.
Okay.
So I'm not Micktoon, just so you know.
What is it? MC Toon. Okay.
I'm a rapper like MC Hammer.
Yes.
There you go.
MC.
It's all right.
Okay.
It's all
Sorry,
right. People say it all the time.
You should make the C smaller. That's how we would do it.
If I were Scottish, I would make the C smaller.
Oh yes, it's not Matt MC. That's right. Yes, buddy, quite right.
The colon says you're English, not Scottish.
Yeah, it's not about me, but look, it's about the water that you think on the kitchen floor, which was built level using a spirit level to ensure the water doesn't run off and tail off. So you're saying that on the kitchen floor, the water is curving. So my question would be to you, by how much and how have you measured this curvature on the kitchen floor?
Curvature has been measured, certainly. I can show you that. Give me a second here.
No. We're talking about the water on the kitchen floor.
Yeah, well, I haven't measured the water on the kitchen floor. The problem with that is in order to find if there is curvature or not in that small of an area, the resolution of your measurement needs to be extremely, extremely good. And, I don't have access to that kind of
So is that puddle
device.
Flat or is it curving?
It is definitely curving.
It's definitely curving. By how much?
By a very, very small amount. It depends, of course, on the size of it, right? And if we're
so you think, MC2, you think on the kitchen floor, on that puddle, there is an apex that's higher in the middle of that puddle?
No. Higher in elevation, no. But higher, different in orientation to the opposite sides of it, yes. So don't.
So you're saying the water is piling up? No.
Misunderstanding how it works isn't.
Go on, explain.
Yeah. It is curved. Let's just say it's curved.
How do you know it's curved? What's the rate?
So what you would do then, if now on a kitchen floor, it would be difficult because, like I said, the resolution of any instruments would be necessarily very big. But instead, let's go to a larger scale because there are instruments that are much more readily accessible for a larger scale. Let's say we go half a mile over.
Well, why do you think water acts differently in a larger scale?
It doesn't act differently. It's just easier to measure because the resolution of the measurement device doesn't need to be as high. You understand that,
well,
right?
If the water doesn't pile up and it lays out flat and level, how are you going to measure it?
It's not flat and level. It's level, not flat. It's level
at rest. It's when it's at rest.
Yes.
So
I'll go over it. What you do is you'd go to one side of an area, and you'd establish a certain elevation above the water, and you'd place a marker there.
Yeah.
Right. And then you'd go to the other side and you'd do the same thing. You'd establish the same elevation above the water to as good of a degree precision as you can. And then you place a angle measuring device, an angleometer, if you will, that measures angles. right? Now we have them, they don't call them angulometer, which I would totally call them that, but they call them theodolites, right? You've probably heard of it, right?
Yeah, sure.
Okay, so you'd place a theodolite on the other side at the same elevation above the water.
Okay.
As on the other side. Now, here's the hypothesis, if the Earth is flat, when you measure across that and you measure the up and down angle, the zenith angle, it will come to 0, right?
What about the atmosphere, though?
That's a good point. The atmosphere will cause the distant object to appear higher. So actually, if the Earth is flat,
because what the surveys are saying, after a mile, it's distorted. You can't really get accurate measurements, right?
It introduces a larger margin of error, is what it does. But you can still measure.
The only way to get accurate measurements. Have you heard of forced line?
Yeah. But here's the deal. We're talking about how to do this, so let's not change the subject yet, okay?
No, I'm just saying to you, there's problems with the atmosphere.
Yeah,
because,
absolutely. And so here's the deal. Here's the cool thing. The atmosphere is known, that the effects of it are known. It will raise up the distant object by a certain amount. That's what the effects of the atmosphere
are. But again, we don't know how the atmosphere actually works.
Actually, we do, because that effect has been measured. On my website, mc2.net, hold on, mc2.net/refraction, the effects of refraction have been quantified many, many times over centuries. So how much it raises things over different surfaces has been quantified. So yeah, it raises the apparent height. So if the Earth is flat, not only would you see it at 0 degrees, you would actually see it slightly higher, right? Not much.
No. Again, that's not what would happen if the Earth was flat. No. Well, if the Earth was flat and the atmosphere acted like a magnifying glass,
the atmosphere does not act like a magnifying glass.
No, but remember, we're presupposing MC2. Like you just said,
I'm not presupposing anything.
Earth is flat, remember, if the Earth is flat and the atmosphere acts like a magnifying glass,
it doesn't act like a magnifying glass.
Yeah, but you don't think it's flat either.
Yeah, but the effects of the atmosphere have been quantified. But look, some people say
the presupposition is valid until you can demonstrate the atmosphere does not act like a lens. Remember, if we can practically demonstrate, I can show you a practical demonstration.
So here we go.
A practical one, real world demonstration of the atmosphere acting like a lens, and we can replicate the sun and ships and buildings disappearing. Let me get that all for you.
Yeah. So the effects of atmospheric refraction have been quantified, and I gave you the link to that.
Yeah, but what you have, your scriptures versus a practical demonstration. Remember the hypothesis stage.
That's not a
remember
scripture.
if experiment disagrees with hypothesis, it's wrong.
Yeah, now, sure. Now you just need to show that once.
We have. I'm going to post you a video here. Now we have a hypothesis that the atmosphere acts like a lens and causes the sun to remain the same size, causes objects to disappear and buildings to disappear. That's our hypothesis. Remember,
now what are you presupposing in that?
I'm not presupposing MC2. That's part of the hypothesis.
You are presupposing some things. You are presupposing that the sun should shrink in size because it's close. You're presupposing a close and local sun.
Our hypothesis is if the Earth is flat and the atmosphere acts like a lens, like a magnifying glass, then, we should expect certain things, like what we see in reality. Now, obviously, if experiment disagrees with hypothesis, MC2, then we're wrong. You don't even have an experiment where, look at this here. I'm going to post you now. I've just sent it to you in your chat. This is our experiment replicating what we see in nature. Now, in order for you to refute and disagree with this experiment, you would have to show your experiment to show why it's wrong.
Certainly, and of course this is Rob Skiba.
God bless Rob Skiba. Absolutely, yes.
Yeah. So let me pull it up so people.
We're men of science, and again, unless we see in nature,
enjoy the chuckle.
Unless we see in nature and are able to replicate it with experiments, MC2.
Absolutely. And I already gave you the link to all of the experiments that have been done.
You gave me a paper.
Yes,
Okay,
exactly.
papers are not experiments. You need to show practically like what we've shown here.
Are experiments. That's how the scientific community works. If you'd reject science, that's fine. That is the typical flat Earth argument: is I don't like science, therefore it's flat. And you're just saying you don't like science. That's fine. I totally accept that you reject science.
No, don't be like that now, MC2. I haven't been like that to you, right? It's nothing to do with that. The idea is that we have a hypothesis, okay?
No, but
then
you're
we have
rejecting
to
science is what you're doing. That's what you're doing. Is
then we have to
science.
conduct an experiment. Now, you haven't provided an actual physical demonstration of your idea.
Well,
you've written it down. But you haven't presented.
Yeah, I don't
the
care that you don't like the way that science is done. I don't care.
No, not about science. About you. I don't like the way that you are doing things, MC2. You yourself
scientists
present
don't care.
a demonstration of what you're talking about. You, not anyone else.
Yeah,
you.
Yeah. I don't need to. That's the beauty of science. I don't need to do it myself. If it's been done, I don't have to. Now, I've done several things, and we can cover them. But
well, if it's been done and you've done it, can we see your practical, like we're now showing on the screen here?
Hold on a second. Wait. Okay. You did not do this one. Okay, so off the table.
I just said
off the table. I completely reject it because you didn't do it. Sorry. You have to do it yourself only.
You can provide your scientist experiment, not the paper, or yourself. I said either you're someone else or you. Doesn't matter who. Just show the experiment.
Yeah, and I did. I showed the paper. Yep.
You showed a paper, piece of paper.
That's how science is done. It's not
the
done.
Same way
it's not done.
Religion is written down on a piece of paper.
Yeah, but religion is not testable. We already covered that.
Well, where is your test? Let's have a look at your test.
At my test of what?
Whatever you're claiming.
Okay. Well, here I'll show you. How you measure. This is how you measure water, whether it's flat or curved. So let's see.
Okay, remember, this is based on the presupposition that the Earth has atmosphere. Have you shown that it doesn't act like a lens?
Yes, yeah, in previous papers. So here it is. This is Jesse Kozlowski. He measured a lake, and like I said, he went on one side, established a certain elevation above the water on one side, went half a mile away, established a certain elevation on the other side, and then measured it. And it's hard to see on the screen here, but if you just Google Jesse Kozlowski flat level lake, you'll find it.
This is optical observations, which anything could happen because of the atmosphere acting like the way it does.
Well, so you say, but the effects of the atmosphere have been quantified.
We would need a practical force the line measurement to show that there is no elevation drop, or there is an elevation drop. Basically,
it's been done. As I said, it is known and been quantified that the atmosphere raises distant objects. And so,
I hear what you're saying. But for you, basically, what I'm saying is that this could be put down to just an illusion optically. We need a physical contraption to show that what you're actually saying is true. Could be a mirage, for all you know.
Well, a mirage typically includes reflection and not refraction.
That's just the opinion. Again, we have problems like that all day long. Could be this, could be that. Unless we have that actual physical measurement, we will never know.
Well, this is the measurement. So here we go. Let me just go over it so that at least we can cover it, right? So here he put out the distance there. He found a nice part of the lake that's calm. He set up a cross there, 2 pegs. He set up a level. He measured above it. He put his target there. You see the target? He also got a GNSS receiver, so he knows the exact coordinates of it. Measured the height of his target and his theodolite. Then he here again is the height of the theodolite right there in the center. And I'll scroll down. There's a bunch of really nice pictures. And here's the cool thing. Never once was the target at 0. It was always below. And refraction is known to cause things to appear slightly higher. So since it's still below, even though refraction makes things higher, we know that it had to drop on the far side. So that's how you'd measure it. So here it is. The final numbers here. I'll zoom in a little. Too much. Let's see if I can get that. There it is. He did a total of 6 measurements, and what he does is he flips his theodolite back and forth to remove any possibility of collimation errors, and then you average them out. And he found over a distance of a half mile, or it's actually 0.48 miles, that there is a 0.15 foot drop to the other side. So there you go. That's how you measure the curvature of water.
But as I say, there is an alternative explanation, and a practical one for that matter. I mean,
It's
what
been
you're
tested
looking
and
at,
fallen false, though.
but again, that's what you're saying based on an optical observation, which could be miraging, for all you know. You haven't manipulated any variables to be sure.
That's just a measurement. You don't have to manipulate variables for measurements.
See, in order to gain knowledge,
if somebody wonders how long is this marker, you bring your tape measure to it, or your ruler to it, and then you measure it. You don't have to manipulate any variables to measure the length of this, right?
I hear what you're saying, MC.
So you don't have to go into parrot mode from Riley about manipulating variables.
Well, in order to gain knowledge instead of a belief, we're going to have to test things and make sure that the effect that we're looking at, we can manipulate the cause to that effect. See? Otherwise, we're just guessing, and we're just putting in our opinion on what we think is happening. And that's what separates knowledge versus the belief that you guys have. See? Because we know, for example, water cannot conform around the exterior of an object without force.
Oh,
so now we know gravity is not a force, because you've now been unable to show mass attracting mass. We cannot use that as the
did show mass attracting mass. Your incredulity about it has been noted and rejected. So
it's not about my incredulity. It's about you not being up to date with your current science. You see, because Newtonian gravity.
Absolutely.
Newtonian gravity is no longer.
Are you unaware of how to use Einstein's field equations?
Well, we're looking at the cause and the effect.
You can use Einstein's field equations to get 9.8 meters per second squared. Did you not know that?
That may be all good and well, but what we're looking at is the cause.
The point is you're trying to dismiss it, but the reality is that you can use Einstein's field equation. And it outputs the same as Newton's equation.
Okay, that's fine. I'm not even arguing that. What I'm saying to you, though, is when you jump in the air and you come back to the Earth, the former idea was that a physical force, was pulling you to the center of the mass. Now, that idea is no longer in use, because what's happening is the bending of space-time. This is the current science, you see.
Okay.
So the idea that mass attracting mass being a force is fallacious, because obviously you can't demonstrate that, as I've outlined.
I already did.
Yet you're holding on to this archaic view. This is 100-year-old science, and the current science says that space is bent through objects bending time and space around them.
Okay.
But you seem to be holding on to this old science.
Well, they both work perfectly fine. Yeah, unless you can find an example where they don't work. But there's never been anybody successfully shown that it doesn't work.
Well, you see, because the Newtonian gravity doesn't have a mechanism for the pulling.
Yeah, you know what doesn't have a mechanism? Your explanation for the downward acceleration.
I haven't tried to explain it yet.
I know, and that's why at the beginning I asked those 5 questions and you already lost.
But we can go through all of those questions. We can talk about them. Because the point is that your view on these questions are no more than ideas. You have an idea of what you think is happening with these questions, and would like to talk about them. So as we've already found with gravity, you can't demonstrate it to be a force. We know that Einstein
already did.
has superseded.
And Einstein has not been superseded. You don't get to tell scientists whether or not they think that Einstein has superseded Newton. They don't think that. That's just you saying that. That's your straw man.
So
Nobody
what was
says
Einstein
that it was
explaining? What is
superseded.
Einstein?
They work
What's
together.
the mechanism behind Einstein's gravity, and what's the mechanism behind Newtonian?
There is no mechanism behind Newtonian. Doesn't matter.
So how are things being pulled then? Where does the pressure come from?
It doesn't provide an explanation for that. It's a law which observes what happens. It doesn't describe why. That's how physical laws work.
No. So the mechanics, the mechanism behind the pulling, how does that work?
Yeah. Now Einstein explained that, and that's how he enhanced Newton. He didn't contradict it. He didn't supersede it. He brought it a step ahead. In fact, Einstein's field equations, have you looked at Einstein's field equation at all?
Well, I've looked at his explanation of
have you
how
looked at it?
are...
There's a certain variable that he put in there, a constant actually, that's in his equation. That's also in Newton's. Do you know which one that is?
Remind me.
G.
It's been a while.
The gravitational constant is in both Einstein's and Newton's equations.
Yeah, but that's not what we're arguing about.
Oh, well, you're trying to say it was superseded, but it wasn't it wasn't replaced, it was enhanced.
The mechanism, the cause to the effect has been superseded.
Newton did not provide.
The acceleration may be the same, but we're not talking about the acceleration rate or the equations. What we're talking about is the mechanism, the
Newton
practical
did
mechanism
not provide
of mass.
Einstein does.
Mass is no longer a thing. The mechanism of mass attracting mass is no longer a thing because the bending of space-time is what is happening.
Sure. And it's been tested and found correct, unless you have contradictory evidence for that.
Again, if you go with the current science, you would go with Einstein, not Newtonian mass attracting mass.
Let's do that. Go ahead. Have you found any falsification?
Are you conceding that it's not mass attracting?
I'm conceding that both work, but if you want to just stick with Einstein, that's fine. How can both work if it's the bending of space-time and not a mechanical pull? That's fine. We can go with that if you can't accept that there is actually nothing in Newton that provides an explanation for it.
No, I'm ready to accept it if you can explain the pulling in this Newtonian.
It's not part of Newtonian gravity.
So how does mass attract mass then?
Einstein explained that.
Well, that's not an attraction then, is it?
It's a force. It presents itself as a force in our frame of reference.
But you know that George Musser told you it's not a force.
Oh, but I did pay attention to that whole interview. If you'd like to pull it up, I can pull up all the quotes here. Give me a second. I'll get up some of the quotes from.
He said you must think of it as a force. Yeah.
He said, yeah.
It acts like a force, but it doesn't mean it is a force. But again, I'm not arguing that with you.
Yes, you are.
I'm trying to get you to realize and recognize that mass, attracting mass, is not a force, that the current science is Einsteinian.
Well, if you
so
can
I'm
just
arguing about
if you can just find some falsification,
that's
all you got to do. All you got to do is find a falsification of it. Find a place where mass does not attract mass. Just go ahead and present. The floor is yours. Present your case where you found that mass does not attract mass.
We've never seen mass attracting mass in nature, have we?
Oh, we have. All the time. But okay, so you don't have anything. I got it. Okay. I didn't expect you would. It was a farcical question, a rhetorical question, if you will.
Well, it's again, where do we see this in nature? We don't, do we?
We see it when things fall. We see it in the planets orbiting, or the moons
orbiting
the planets.
Why are things falling? Because the Earth, the so-called spherical object, is bending the time and space around it.
Yeah, and it's testable, and it's been confirmed.
Which is causing the fabric to bend, which is causing the object to come back, return back, not an attraction. Sure. It's rolling on the fabric of space-time.
So here we go. Here's a quote. FTFE said, "So you can still use Newton's laws to calculate gravity
FTFE getting involved?
Well, this is the interview between Musser and FTFE. Let me read it so you can get the whole thing without an interruption here. It's not long. So you can still use Newton's laws to calculate gravity as a force. Musser, absolutely. So you don't get to use Musser to say that gravity is not a force because his answer was absolutely.
Yeah. What does he mean by that?
He means that it presents itself in our frame of reference.
I'm not arguing
as
that either.
a force.
Again, I'm still not arguing that. You can think of it as a force. It doesn't mean it is a force.
Yeah, but it acts that way. So here's the deal. A question. Somebody was asking this. What are the fundamental forces? Do you know them?
Look, let's stick to the topic. I know you're spiraling right now.
What are the fundamental forces, Spurs?
Can we stick to the topic?
Do you know?
Okay, let's not
the fundamental forces
all over the place.
Do you know the fundamental forces?
Of course, I know the four.
What are they?
Four fundamental. But the point is that you're spiraling now.
What are they?
Let's stick to the topic.
I'll write it down.
Newtonian.
Come on, I'm ready. What are the fundamental forces?
So every time you get back to the corner, you're going to keep asking me different questions.
No. I think what happened is you don't actually know what the forces are.
Well, again, you've got your fictitious force of gravity, you've got your weak force, you've got electromagnetism and the strong force.
Oh, there you go.
Why are you asking me?
You're the first one. Okay, so now outside of that,
again, these are you've got fictitious forces in here. What was the purpose of asking me these questions?
So there are.
Why are you derailing the topic? Why are you gatekeeping?
Here's why. Here's why
that we have to ask you.
You ask me the question, I'll answer your question. Is gravity one of the four fundamental forces in Einstein? It is not a fundamental force in Einstein. It is a fictitious force in Einstein, like centrifugal force, for example. It still is something that we must use when we're calculating things. It still is a force, just like centrifugal force is. So it's not a fundamental force in Einstein, but it is still a force.
Okay, so let's make this easy for you. So let's say we've got a car, a Lamborghini. Now, what powers that Lamborghini? We may have fuel, like petrol. I think you call it gas over there.
Yeah.
Okay. So the car can go 100 miles an hour. So what we're going to do now is change the cause of what makes the car accelerate. So before, it was fuel, which was Newtonian. Now we have something else causing the acceleration. We could say somebody's pushing it at 100 miles an hour. So we have the same speed, same calculation, but what we have is the cause to the effect, MC2, is different. That are the two differences. Those are the two differences between Newtonian and Einstein. One was a physical pull, and the other is the bending of space-time. Do you understand the difference?
I do. And in the end, though, the Lamborghini is going 100 miles an hour.
Still got 100 miles an hour. Still the same, but the effect.
So that's fine. So let's just use. We'll just use Einstein for this, and I'll rely on you. I'll rely on you to do the math because it's a bit much for me. I gotta be honest.
You supported Cavendish by saying this is the fuel. When the fuel is not there anymore, we have a different cause.
That's not actually how it works.
So what is the, well, this is what we're trying to find out. So which is who's causing the car to move, the fuel or the push?
Well, you have two separate explanations that are independent of each other.
Two different mechanisms, that's right. Einstein has one mechanism, Newton has a different mechanism.
Newton has no mechanism. Newton has no mechanism.
That is a pull, a mass pulling objects.
You don't get to straw man Newton. Newton did not provide a mechanism.
When the apple fell from the tree, it was being pulled towards the center of the mass. Physical pull.
Yes, mass attracts mass.
Yes.
But that's not
that's not what happened.
Mechanism.
No.
That's not the mechanism.
Einstein said that the apple and the earth are moving towards one another.
Sure.
And Newton said the apple's being pulled towards the earth, not pulling the earth towards it.
Yeah. If you just play semantics, you still don't win because there's still mass attracting mass. All you need to do is provide a falsification of that, and then we'll have something. You got anything?
I'm not arguing with you about the rate that they might meet. I'm talking about the cause and effect.
Yeah. Okay. Don't care. I really don't care. Neither does science. You're actually the only people that you're impressing would be other people that don't understand science. Which
so if there's an effect, you don't care about the cause in life.
So, all right. Hey, let's get a couple people are asking some things, and you've kind of gotten yourself into a spiral here. So let's go with NASA Black Site says, please let Schemo know. Cypher says hello. Cypher says hello. I don't know
what is that.
I don't know. Morton Nielsen, for 45 Donkey Kong dollars, says a kitchen floor are rarely flat nor level in the first place. So that point is not really a point, Spurs.
Yeah, every kitchen floor is level and flat.
To what margin of error is the question. And I don't know if you really, do you understand margin of error?
Well, there was no elevation drop, put it that way.
Well, so you say. Okay. Swedish Vapor UK for £5 says, this geezer, that's you, I think, is bamboozled by his own discombobulated brain farts. Flat Earth is dead. It is an X theory. It has shuffled off this mortal coil. Genius.
Well, I think
It's
the reason
pining.
that you're here,
Pining for the fjords. Is that what you think?
Was that a super chat?
That was.
He thinks that flat Earth is dead or dying.
Yes. Well, it didn't even start because you don't have a map. That was my first question.
Well, I think the reason that you guys are here defending something that doesn't exist shows how quickly flat Earth is growing and how big it's become.
We have maps right here. We have maps. You can use a global map to chart international routes. You can use the Haversine formula to find out the distance. Flat Earth has nothing for that. So, I mean, step one, get a map. Right, back before people did international travel very much, then you could get away with not having a map, but not anymore. So millions and millions.
You have an idea.
Yeah, it's not an idea. It's a real thing. People really get on airplanes and really fly places. They get on ships and they really get to where they're going using global navigation. They don't ever use, for these long distances, they don't use flat maps. They use global.
And all those pilots that we've seen online say the Earth is flat.
No, they don't. But I've been asking and begging any flat Earth pilot, come on, let's have a talk. But no, they always disappear as soon as I do that. So
maybe you get one-on-one.
Let me see here. FDFE owes you a family-sized pineapple pizza for making you have Spurs on. Make sure you collect as soon as possible.
He set you up. He did.
He did. Fortunately, I took 33 Tylenol just before this, so I'm good.
Okay.
So thank you.
I mean, again, look, I understand how difficult it is to be lied to, right? I mean, I understood the Earth was a globe at one time.
I debate flat earthers every week. I do know what it's like to be lied to.
No, I mean about the shape of the Earth. I mean, look, you're in a position where you cannot prove physically your claim. You have the
mctoon.net/burden. There, it's all there. It's all there. Go
Again,
ahead.
these are your ideas that you have. You don't have. If you actually had practical demonstrations, you would be showing it right now.
Well, I mean, we could go to mctoon.net/.
I mean, I'm ready. Look, we're looking for proof.
I already showed you a measurement of the curving of water over a half mile. I mean, you have nothing. So, you already lost.
Well, what we have is history, and history tells us that the Earth is flat. They've always known it was flat. And remember, a group of guys came along with an idea.
You need measurements. You don't just need nuh-uh. All you have is nuh-uh. Do you have measurements of flatness?
Again, I said we have history, and history tells us that the whole entire civilization knew it was flat, and a group of people came along and said, it's a ball without any proof whatsoever.
And then measured it. Like I said, we have measurements. I showed you a measurement. And you said, nuh-uh. Do you have measurements?
It's not because, again, you need gravity for water to conform.
Do you have measurements?
No, again,
do you have measurements?
It's not about
any measurements.
No measurements. We have science.
I know you don't have measurements. There you go. Thank you very much for that. So, all right. Well, let's go in here. Mage Kind for $5 to Spurs. How's your back? You need to team lift for those goalposts, you know. That's right. Don't stress your back when you move those goalposts. Right? Just looking out.
I do try to stay on point. I think you'll find it was you who just asked random questions out of the blue.
I'm reading super chats. That's why they're random out of the blue. Ilya Latez says, Spurs, when you ask a question, shut your trap and listen to the answer.
Yeah, absolutely. I'll absolutely try and do that more for the audience. Yeah.
Schrodinger's cat says, back to this. Spurskimo. He doesn't think you're legit, man.
I mean, there's only one way to find out, right? That is to prove that we're on a spinning ball flying through space, and all of this nightmare for you globers will be over.
Yep, it's yeah, we're past that. Like I said, you should go mc2.net/burden and look some of that stuff. So all right, we've got Irish Demon has some notes and then says Tinky Winky, Dipsy, La La, this guy. I think he just called you, let's see, what comes after La La in that sequence?
Well, you've got La La Land. Is that's
no.
that comes
Tinky Winky, Dipsy, La La, and...
Oh, you're talking about Teletubbies.
What's the fourth one?
I don't really watch children's.
Poe. So I'm telling you, man, people do not believe your sincerity. Now, I did get one person that does, to back you up.
Well, again, it's not about. See, the problem with you and most people here, it's all about opinion. Okay, and what we need is a bit of science to have knowledge.
Yeah. Well, it's not just opinion. I've got some open tabs here.
Yeah. Let's have a look. Let's see what you got.
Right there. Here's my tab. I have another tab. Do you like tab? Do you like open tabs? I have many open tabs. Let's see. 1, 2.
Oh, these drinks. Yes.
3 and 4. Right there. I have 4 open tabs here.
Very funny.
Do you like tab? Have you ever had it?
I've never tried this.
I don't recommend it. It's terrible.
I don't think we get this. So, I mean, there are so many things you would find difficult to. I mean, you may have the explanations, but you'd find difficult to demonstrate. I mean, we have so many things on our side. For example, gas pressure. I'm sure you're familiar with that argument by now. Explaining the vacuum of space without the container itself.
Oh, yeah. Well, of course, gravity is a container, and space is pressurized. It's not a perfect vacuum, so...
Again, you see, how do you know from when I hear these things, to me, they're part of the model. So when you're explaining these things, all you're doing is explaining the idea that comes with the model. Now, again,
I can give you better than that.
Go on. Can you do?
You agree that things are accelerated down, right? Matter. If you drop something that has mass, it's accelerated down. Right.
I mean, it's difficult to say. I mean, again, the objects.
It's not.
If they're not in equilibrium, they're in disequilibrium. Again, down. Is there direction of down? Is there any? I mean, again, these are the questions that we're trying to find out. Because if it's not gravity and it's not pulling, then
here's the deal.
What dictates direction?
Is there something that pulls mass down?
No, absolutely not.
No, it doesn't go down. So if I drop something, if I let go of it, it'll go up, left, right.
It depends on the medium that you're in.
Okay, so the buoyancy is a thing, absolutely. So if the buoyancy of the object and the buoyancy of the medium are the same.
No, buoyancy is the idea that there is gravity, a force pulling in the opposite direction. Again,
buoyancy
that's the
certainly
idea.
exists if you take a ball.
But remember, if we're looking
underwater.
about MC, let me speak a second.
Okay.
Now, if we're talking about science again, cause and effect. What is the effect?
That's not the only way to do science. But go ahead.
Okay, so if we're talking about cause in this case, and what is the effect? We've got an object moving in a direction. What direction? That's up to you. But what caused that? We can say the density, or we can say the medium that it's in. It's relative. Yes.
Well, keep going.
That's what it is. So again, have you seen the density tower?
Yes.
The density tower. Yeah. So obviously, if you drop an object in that, depending on the temperature, I'm sure you've seen where you pour hot water in container and it can move objects laterally. Yes.
I don't know. Go ahead. Continue.
So depending on the density, obviously, that will control, as we understand, the direction. So there is no down. There is no real direction here.
This is new science. This is groundbreaking stuff here.
Well, again, like I say,
you're gonna get that Swedish prize, man.
again, we can test this. We can take objects, we can take the medium, and obviously, depending on the density, the direction will follow.
Here's the beauty of that. You can use Newton's universal gravitational law, or you can use Einstein's field equations. Either way, you'll still get about 9.8 meters per second squared. Then you can use the formula for density, or for buoyancy, right? And all of that we can test and confirm. And so we can, all of that works. Now, do you have any explanation for why a balloon that has not a lot of helium in it, but some, and it'll just kind of, right, hover in a room? Do you have a testable hypothesis for that?
Why a balloon would just sit in the middle of the room?
Yeah.
Well, we'll just explain that.
A testable hypothesis. I'll write it down, and then we can work on it, and then maybe I know people, and we can get you published and then get that prize. Can I get a little, maybe 5% if you get that million?
Well, you could take it all.
Oh, awesome. Okay. So what's the testable hypothesis? People, I'm big time
depending
here.
On the medium,
getting that prize
of what that balloon is in.
Let's say
we'll
it's
give
air.
You the results. Or if it's air, yeah, it was depending on how much of helium, like you said, is in that balloon. We'll position it in the middle of the room.
Okay.
What are you looking for?
Well, the testable hypothesis, that's the cause, as you
caused it to stay there in the middle of the room.
You love cause. What's the cause?
What caused it?
Yes.
So you've got the container, which kept it contained, the gases.
The balloon is the container, yes.
Yeah, so that if you remove the container, it doesn't stay there, right?
But that's we're talking about why is it hovering at that particular level?
Because you've got the container there, yeah.
Yeah, but what's the testable
hypothesis? Right amount of
helium
in the medium of air.
Yeah. So what's the testable hypothesis?
So you can test that underwater and see if you get the same result.
No, but you didn't give me the testable hypothesis. You're just telling me. You're just telling me the observation again.
My predicted cause is the medium change.
Okay, and so how do we know where in that medium it's gonna find rest? It's gonna be at equilibrium. How do you test?
How do you know
that?
Where?
Yeah, so you have in air.
Well, if it's not in the container,
there's a gradient, right? It's denser here than it is here. If it's not in
the container, it will go anywhere, or the helium will rise. I'm not talking
about that. We're talking about what the balloon. The balloon will find some position in the gradient. Yeah.
It's called equilibrium, MC2.
So it will find that equilibrium. But but how do we predict where? Because I can predict where it will find that equilibrium. Can you?
Yeah, like I just said, you got to use. You just said the right amount of helium will tell you where or how high it will go.
Yeah. Okay. So let's say we know the mass of the balloon.
So let's say, for example,
and the mass of the helium and air mix inside the balloon, and we know the density of air here and the density of air at the top of 100 foot high, 100 meter high silo, let's say, and we know the density gradient from top to bottom. Knowing the mass of the balloon then and the quantity of air and helium in there, how can we test so that we know where it's going to happen, where it's going to hit that equilibrium in your model?
What's the effect? What's the observed phenomenon?
That's your shenanigans. I'll let you describe that.
What are we questioning? What's the observed phenomenon?
That would be that, I suppose, that the balloon finds an equilibrium at some elevation.
Okay,
so what will be that? So we want to test
your phenomenon is what? The balloon was at an elevation. This is not a natural observed phenomenon.
Well, but is a helium balloon a natural phenomenon? Wait a second.
Is a helium balloon a natural observed phenomenon?
No,
Did you seriously just ask me that?
Of course it's not. And so are you saying that you can't use a helium balloon in science?
Is it a naturally observed phenomenon?
A balloon is not a naturally observed phenomenon, no.
So what are you asking me about it then?
It seems that you don't think that you can use a balloon in science. Can you use a balloon in science?
Well, how are you going to use it in science?
Well, you form a hypothesis and see, test it.
You only form a hypothesis for a naturally observed phenomena in nature.
So are you saying that a helium balloon cannot be used in science?
But what's your cause and your effect?
No, yes or no? Can you use a balloon with helium?
I'm trying to find out how. How would you do it? I'm asking how. How? I don't know how. How would you do it?
Reason why you're avoiding just the simple yes no? Are you allowed to use a helium balloon?
I have no idea. When you say a balloon,
I believe that you have no idea.
What's the cause and what's the effect?
You keep going. You're like, you want to reject science by saying natural, right? But then you're going to use not natural things in that science. So you got to pick. Can we use a man-made device in science or not?
This is why I say we have to kind of educate you guys on how to conduct science.
I'm sorry, you don't get to educate us on science.
Yeah, we have to educate you guys. So look, we're talking about
there's no flat earther that understands science. It's a core principle of flat earth is to reject science. That's an absolute fundamental part of flat earth.
Let's see if you disagree with what I'm saying then. So you see something in nature, an apple falling. This would be considered an observation in nature. It's natural. We didn't disturb it.
Natural,
it just fell.
In science, natural means anything that's not supernatural or spiritual. So that's when you look up what science says and what it can explore, and when it says in the description for science, for what science can do, that it's natural, that means it's not supernatural. So it's not a thing that can explore religion, for example, or a belief in God. That's not what science does. So everything in the physical world then is what's natural. It's part of nature. The universe is part of nature.
Yes, but what we're looking at is cause and effect. So if the apple fell from the tree, then we can ask, did somebody cut it from the tree? Did the wind blow it? Did it fall naturally? What caused that just to fall in that way? And then we can conduct a hypothesis, yes, and then follow that up with an experiment to test your predicted
what
cause.
Experiment? Wait. You can't do an experiment if you're going to be doing things that are not, according to you, you can't do it because it's not natural as soon as you do an experiment.
I'm educate you on this process. Now, remember, we saw things in nature, apple fall. Now, obviously, to try to
when
replicate
science says nature, it's not meaning it just
okay,
is
fine,
there.
Whatever you want. But the idea is that now we need to replicate this apple falling with our predicted cause. So if you think a force is pulling it, you need to demonstrate and manipulate that cause. So if we think, for example, the medium, we can change the density of the medium and have the object rise or fall, then we have our cause to the effect. Now you still are trying to figure out, well, why did it fall? What's going on?
And already,
you haven't been able to manipulate.
Mass attracting mass can be manipulated with a torsion balance.
That, but you haven't been able to manipulate your cause.
Of course, here, let me explain it, and then you'll understand. Well, I can explain it to you, but I can't understand it.
Let me finish my point off. So, you keep interrupting me. So we have an acceleration, you said, of 9.8 meters per second. Now, if you're saying gravity causes this acceleration, you should be able to slow and speed and stop this acceleration with your cause. So if you drop your ruler, you should be able to reverse that, stop it, slow down the acceleration because you are in control of that cause.
So,
but now we know if we change the medium, that ruler will fall at a slower rate. If we change the medium again, it can fall at a faster rate.
That's a great point.
Involved.
Okay, so here, let me explain. Let's because when you do things, you want to control the conflating variables. And ideally, it makes it easiest if you have one thing changing instead of 2 or 3 or 4. Obviously, it's difficult to control everything, but what you do is you get things so that their influence is very small. So what you do is you use an evacuated chamber, and you have the amount of air pressure inside that evacuated chamber the same wherever you go. And so then you can manipulate, because the hypothesis is that gravity is causing it, right? So the distance from the center of the Earth to the object is part of that. So you can vary the distance from the center of the Earth to the object and measure to see if the quantity of downward acceleration changes. So what you do is you go maybe on the equator at sea level, use an evacuated chamber, measure the downward acceleration. Then you go to a high point, maybe near Mount Chimborazo, which is in South America, a high mountain right by the equator there. And then at high elevation, where you're farther from the center of the Earth, you test to see if that acceleration changed. And in fact, it does.
Okay, again, that's the idea, and that's touted, that if the Earth were a ball and gravity was a force, and things like what you've just outlined would happen. So, in order for that to be true, and for order for us to gain knowledge, do you have a demonstration of your claim?
Yeah, people have done that. Yeah.
Okay, again, so it's an idea that people have done this. That's part of the model. The model is to say we have a map, we have a model, we have measurements, we have science. That's part of the model. Now, in order for that not to be an idea, do you have here and now in real time a practical demonstration that we
neither do you.
See
right.
that we can replicate?
People have tested that hypothesis already. So all right. And all you're going to say is that you reject how science is done.
I haven't rejected it. I said it's your idea.
So
in order for it not to be an idea, you would have to show a demonstration for it to be fact.
Yeah,
you can't say your ideas
been done.
are fact.
So here's a good thing from PhD Tony, who is he's a PhD and he deals with gravity all the time. So he says the mining industry uses gravimetric mineral exploration to locate subsurface ore deposits. You know this already, Spurs, because I explained it to you. It is a practical demonstration.
Again, MC2, I like the ideas that are going around about the Earth, but what we don't have is a demonstration to prove this idea. So now, some people are saying this is a religious idea. So you're saying it's not. So if it's not a religious idea, how do we demonstrate this to be true?
In incredulity, I got that. Got it.
I haven't doubted it. It could be true. All right, how do we prove what you're saying is true?
Fred renamed it. Oh my gosh, he calls it the Dunning-Kimo effect. What do you think of that?
I think I said I could be wrong, you could be right, but the only way we're going to know that if I'm wrong and you're right is by demonstrating the
why
idea.
Why don't you go find that it's wrong? Now just this is on point here. You see, this is a mug that says the Riley-Nodell effect. And if you look up the Riley-Nodell effect, you'll find its definition is it's a synonym for the Dunning-Kruger effect. And now, but Fred has proposed a modification of Dunning-Kruger to Dunning-Kimo. I don't know. What do you think? Do you like Dunning-Kruger, Dunning-Kimo, or Riley-Nodell?
I mean, I don't understand why we are attacked in this kind of way. All we do is ask questions.
Well,
all asking you is,
as I said, you lost before you came in because you don't have a map. But let's see. Now, Saeed Ahmad, I don't think he's a Spurs fan. He says tune greater than Spurs. He did have a little insult there. I'll skip that. He says he's out of his league. So now I don't play baseball. Do you play baseball? I've never been in a league. I mean, I was in Little League. I was in Little League.
Rounders, yeah. Rounders, baseball, yeah.
Rounders, yeah.
Yeah.
So I was in Little League. I did T-ball. Do they do that in England there? T-ball?
T-ball, no.
They put the baseball on the tee. And here's what happens, because there's no pitcher then, right? I get up, it's my turn. And I swing and I hit the tee. So they set it up again. They put the ball back on the tee. And I swing and I hit the tee again. And then they put the ball. And I swing and I maybe go above. Anyway, after several tries of hitting the ball and not hitting the ball on T-ball, they're like, why don't you just go have a seat? So there you go. I struck out at T-ball. It's my dark secret there.
Why do you think it is difficult for your side to? I mean, you don't have to. I just want to talk. Just ask your opinion on, because you haven't really presented. You've given me a paper. You've given me the idea, but why? I mean, this has been going on for years now. I've been doing this for more than 5 years, 6 years now, and it's pretty much the same. We have papers, but no demonstration. Why is that?
Well, I'm like I said, I've done my own measurements. I measured the angle to the sun at 3 different times of year, and then hypothesized 2 things: that the Earth is flat and that the Earth is spherical. So based
You
on
wouldn't be able to measure the sun.
what's that?
Because remember, if we presuppose that the atmosphere acts like a lens, acts like a magnifying glass, and we have a demonstration to show that with this, what I posted for you in your chat box there, then your measurements to the sun would be off.
Yeah, and I take that into account at because, like I said, the effects of refraction have been quantified at elevations above 15 degrees. The effects are very small, and the effect of refraction was actually smaller than the margin of error of my measurement of the length of the shadow. So it was I mean, I did include it in a measurement, but it modified the elevation of the sun by a tiny amount. Anyway, so
I'm not doubting you did it. I'm not doubting.
Yeah, so I did
that,
it. I measured for flat Earth. I measured the elevation of the sun.
If the atmosphere acts like a lens, you're going to get incorrect results.
Yeah, but it doesn't, and it's known. So then, because you've never shown a practical demonstration of the atmosphere acting like a lens, you've shown a lens, and that's it. You didn't show that the atmosphere acts like a lens. So I understand you don't have that. So anyway, the point is, I measured in September the angle to the sun right around 45 degrees. Happens that I'm at 45 degrees north latitude. Putting the sun right around 3,105 miles in elevation. And then that night, 12 hours later, the sun was nowhere to be seen, but I did the math and I calculated the elevation of the sun, according to flat Earth, that it still must be somewhere around 15 degrees above the horizon in the middle of the night, and it wasn't. It had already set. Therefore, the Earth is not flat. Then I hypothesized that the Earth was spherical and the sun was not near, but it was very far. And I took my measurement and 3 or 4 other measurements, and then different times of the year we also did that. And we measured then, with that hypothesis, the radius of the Earth. And all of us at different positions on different days got, within a small margin of error, the same answer.
Again, I mean, a lot of these things probably would be more, because it is a belief, and if you want people to believe you more, I think if you could just even back up, like the gravity, mass attracting mass, if you could just back up things falling at the same rate, when objects fall in the vacuum, we're told if you drop like a metal object and like a feather or something, they fall at the same rate. But what we found is with Brian Cox's BBC, they cut and edited it, and they put it in slow motion, and it was more like a movie than actual science. So when people try to replicate,
that wasn't a science experiment. That was just a demonstration. So
like a movie, yeah. So when people try to replicate objects falling at the same rate,
who replicated that?
Sorry,
who tried to replicate that and found it to not be true?
Yeah, let me get you this. 1 sec.
I mean, that's Nobel Prize right there, dude. That's
yeah. I mean, people have tried. They thought, I've seen Brian.
Maybe it's just garbage, and you'll just get a Bob Nobel Prize, which is not very valuable at all.
Well, like I say, people have tried to replicate what they saw, but again, if it's just television and if it's just made up, then you're not going to get the same results. So let me send you this video here. So I was able to compilate at least 4 or 5 experiments, you might call them, where objects are supposed to be falling at the same rate. So you can play this from, I'll tell you where to play it from. Skip from, go to, you can start from 2 minutes 20 seconds. You can just play it and we can talk about it as they're playing. Okay. Put it on site. You don't need sound.
There it is.
But
who edited that? That's terrible. My goodness.
Yeah, so these are just various start from this one there, yeah. So as you can see, they tried to replicate the objects falling at the same rate. And what we find is that objects do not fall at the same rate. You can put it on fast speed if you want, or just flick through it. The best one is the long tube, because you might want to use a longer tube.
Oh yeah, definitely longer.
Yeah, longer tube. So check this out. So when you go to 5 minute 26 seconds, 5 minutes 20 seconds, there's a long tube, and because they're so sneaky, so you 5 minutes 29 or 28, somewhere around there, because you get a good shot of that one. So watch what happens. Let me explain. So when the guy recording it realizes that they don't fall at the same rate, he pulls the camera away to try to
now you did this yourself.
No, watch the video.
Oh, I'm sorry. If you didn't do this yourself, you can't allow it by your own rules, Spurs. What are you talking about?
I'm saying the observations.
No, you didn't do this.
You see it.
You didn't do this. Your own rules.
That,
yeah? You can't show this if you didn't do it, Spurs.
Yeah, but you saw that, yeah?
I did. But here's the deal. What part of that was natural? Is that tube found in nature?
No.
Okay, so by your own rules, we can't even look at that. So
this wouldn't be science, no. But this is your science. This is what you would say is science, right?
I don't know. It's so confusing there because you didn't do it. And no, I didn't do this. That is your. But that is your.
Idea. Remember, it's just an idea.
I'm making you be consistent with your own rules. Those are not found in nature, therefore you don't accept them, and you did not do them, therefore you won't accept them. So, man, that's embarrassing for you, isn't it? To not be able to even use your own evidence because it doesn't match your own standards of evidence.
So you don't accept that video, yeah?
Do you have anything?
I'm just saying, do you not accept those experiments there?
It does look pretty interesting. Now, here's the deal. I'll go back to this because I got no problem with it. Now, I understand that you will reject all of this to be consistent with yourself.
No, I'm just saying, I don't mind if you don't accept them.
So now So here's the question now. My first question is, did it say the pressure that they were able to get in here? Did you...
it was a vacuum.
Yeah, how much vacuum? What was the actual pressure in the end?
I'm not sure.
Oh, well.
What should it be?
Well, I don't know. And if you don't know, then how can we calculate our expected...
This is your science. This is your experiment.
Oh, absolutely.
You think
Here's the deal.
Fall at the same rate in a vacuum, right?
But no, well, of course, there's no such thing as a perfect vacuum. So since there is no perfect vacuum ever... There is an imperfect vacuum in there. So what we can do then is, knowing, if we knew, but you don't, the actual pressure in there, then we can hypothesize what the drag would be on both of the objects from the amount of air that is in there, which you don't know.
I agree.
So we can't actually test to find out.
I agree.
Yeah, so
I can't argue with that because, again, this is my point. We don't have an experiment that shows objects falling at the same rate anywhere.
Well, you don't, but yeah.
Neither do you.
So, all right.
Do you?
Let's I'd just go to the Brian Cox was a pretty good one. So, but let's do this. I got some, we're getting close to, we only got 20 minutes left and then we hit 2 hours and I don't know if do you want to go more than that? I think we should try to not go much more than that.
No, 20 minutes is fine. 15 minutes.
So, but I got some questions. I think it'd be nice to, rather than have just me hog the time here, right? Let's let some of these other people. So Stan Grabowski is asking, ask Spurs if every previously known fact has to be reestablished in every experiment ever done. Does every experiment have to test that 2 + 2 = 4?
2 + 2 = 4 is not an experiment.
Yeah. So his actual question is, if every previously known fact has to be reestablished in every experiment.
If it's a wild claim, yeah, then you have to show that it's true. Yeah, of course. Every generation will want you to demonstrate that what you're saying is true.
So
So the
everything.
next generation will want to know, if they're thinking critically, the next generation will want to verify what they were told by their
Sure,
peers.
yeah, it's always good to reproduce things, and that's a fundamental thing. If you ever had gone to university and studied physics or something, a whole bunch of the fundamental experiments are what you do through the course of a physics degree.
Yeah, but that's how we're here, because by applying these rules, we understand they do not work in reality.
Well, if you only had that to show. So, Truth Nerd says, show me a practical demonstration, but not optical. That's a good one. Do you have any practical demonstrations that are not optical?
What does he mean by that?
Well, a practical demonstration that is not optical.
What does he mean? What does he mean?
I would say something that doesn't use optics to do it practically. The practical demonstration that's not based on something that we see. Because you keep asking for a practical demonstration, and then I show it, and you're like, oh, but that's through the air, and air affects things, so we don't know.
Oh, yeah, I get what you're saying.
You throw your hands up and say, we don't know, therefore I'm gonna use the nuh-uh card.
I understand. Get it now, yeah. So obviously, if you're just looking at something, that's not an experiment. If you're looking and doing something practical, i.e. a measurement, i.e. Doing stuff step by step with a procedure, then yeah, that would be considered an experiment.
But it's optical if you're looking at it somehow, if your eyes are involved.
That's right, yeah.
Yeah.
So that's correct.
So you're going to reject it.
You're not staring into thin air. Yes?
Yeah, you'll reject it. All right, that's fine. You won't accept anything according to your standard of evidence. That's fine. So the NASA Black site says, ask Schemo when he's releasing Saddam's flat info. I don't know what that is.
What does he mean by that?
I don't know. NASA Black site. What do you mean releasing Saddam's flat info? I kind of figured you'd have some context to that.
No, I thought that was addressing you. I thought you might have known.
I have no clue. Saddam Hussein is the only one I know of. So, all right. Well,
his username is Saddam Hussein.
What's that?
His name is Saddam Hussein.
His name is the NASA Black site.
Oh, okay.
I don't know. All right. Morton Nielsen. Scotty, I need full power on forward deflectors. I'm giving it all she's got, Captain. I can't talk with the Scottish accent. Like I said, I'm not Scottish. Can you do a Scottish accent? Can you say, I'm giving it all she's got, Captain, in Scottish. Can you do that?
Aye, Captain.
That works.
Is that any good? Any good?
Yep.
They can use that for their ringtone.
There you go, people. You got a new ringtone of Spurs saying aye, Captain in Scottish. Now, I know you're not Scottish, but are you familiar with Scottish sheep units?
Yes, of course.
I have a soft spot for the Scottish sheep units. I like, is there particular, like, different Scottish sheep unit that you like more than others?
The kilo sheep length is one.
The kilo sheep what?
Kilo sheep length.
Absolutely.
Kilo sheep length. Yep. Kilo sheep.
Now, a sheep length is 4.33 feet.
Okay.
Or 1.32. Yes, but
a kilo sheep length is 0.82 miles.
A kilo sheep length is what?
Is 0.82 miles. So that's 1.32 kilometers. A kilo sheep length.
That's it.
Have you ever walked a sheep mile?
I have never walked a sheep mile because it's not possible. Somebody fed you this, man.
Okay, so look, can we get serious now and get back to the science? Because this is what we're all about. People think that this not serious.
Oh, wait, hold on a second. Okay. Oh, we got this. Well, we got the. Of course, it's not serious, but we've got the backstory to the Saddam thing. From the NASA Black site said, Schemo once said Saddam Hussein was on the verge of revealing the flat Earth when they killed him. He knows what we are talking about. Oh, Spurs.
What is that? What happened?
You once said, according to the NASA Black site, you once said that Saddam Hussein was on the verge of revealing the flat Earth when they killed him. Is that true? Did you say that?
Oh, no, because they were talking about stories, making up stories, and they were having fun in I don't know if you know Gem Panda's server.
Oh, yeah.
Yeah, so we were like, let's make up the best story, and the ballers were doing it, the flat earthers, we were just having a bit of fun.
Are you sure? All right.
Just making up random things.
That's
it's just a joke.
Well, I mean, yeah. I agree. Flat Earth is just making up random things, but that's fine. Okay, so let's see.
We were saying the ball is just a story. So the idea was just to make up the most wild and random story. Like the ball spinning through space is a wild random. Because can you imagine a ball with water around it in a vacuum? What would happen if we tried that on Earth?
Yeah, it'd work fine if you were produce it to set up. I'm really curious, who sent you that Scottish sheep unit thing?
Oh, I mean, I think I've heard about that somewhere.
Oh,
I mean, in Gem Panda's server, we discussed so many different things, so it may have been there.
You had it ready. I'm very impressed. Very good. Let's do this. We've got Cinnamon Control said, I did a test using measurements of the atmosphere, and it proves distant objects are optically displaced upward. I'm sure Spurs would just deny it. So if Cinnamon Control says that he or she did a measurement of the atmosphere, and it confirmed that optically distant objects are displaced upward, they appear higher.
So do they have a practical demonstration, replicate what they see in nature? So obviously we can use man-made tools now to replicate what you think you see in nature.
You can't do that. You're breaking your own rules of standard of evidence there.
You know, like things that again, this is where you guys fail to. You know, for example, where you show the sugar water with the laser bending, right? You've seen that, I'm sure.
Yep.
Okay, so you're trying to explain refraction. So what you're seeing outside in the real world, you're saying light is bending in a particular way, and you're taking man-made tools to replicate what you see. So you're going to manipulate what you think is causing that. That's what you can do. What you can't do is build your device from your mind, just build it, and then say, here is my phenomenon in my device, and then now explain this phenomenon. That's not how science works. We're talking about the natural world where we have questions about things we see out there in the real world. Like things falling, things just fall. You walk along, things just fall. You say, how did that happen? What caused that? You say a force, we say density. We can test that.
Yeah.
So again,
density is, I'm sure you're aware, density is not a force. So,
okay, that's fine.
Now, somebody
we're not saying there's an acceleration, but the idea is, again,
Bat Beal, just got bingo, just so you know. I need a couple still.
Yeah.
All right. So anyway, Cinnamon Control did this. I put the link. I'll send you the link to his channel, his or her channel, so you can look at the measurement of atmosphere, so you can see whether or not you think it meets your standard of evidence. So, all right, we need to keep moving here. Andreas Eld says oxygen was discovered in the 1770s. What did humans breathe before that?
I think why are people asking such silly questions?
Well, because I think it's because of how you said that, like, gravity didn't exist before Newton, right? Of course it did, but people just hadn't been described yet.
Newton, they didn't. Whoever came up with the idea of a ball or globe, and didn't think about how objects would stay on that globe. And then the question was asked, and then somebody had to come up with an idea to explain how objects stay on the Earth. And then gravity was born, and then that's why we have different types of gravity, because they're all different ideas.
Yeah. Sorry,
Quite
I wasn't really paying attention. I'm responding to somebody here, so
I
Uh,
mean, you are saying a lot of gish gallop here.
Here's true, that is what you're doing. So GBG man says, Spurs, why don't you want the Earth to be a globe? Is there a, and somebody else has asked, what was it that you is like, what's in there for you that you really like, you don't want it to be a globe?
The shape to me is not an issue. If it's a ball or globe, it's a ball or a globe. What's the issue or the problem is the lie. Why would they lie? Why would they lie to us about the shape of the Earth? That's more important. That's what we have to find out.
But it's not flat. Like, I mean, you already admitted it. You don't have a map. You don't have elevation of the sun or the moon. You don't have explanation for the downward acceleration, right? All these things that you don't have.
So, again, we don't have an idea of what's under the Earth, how big the Earth is. Nobody has any idea.
You
people an idea.
People do know what's inside, and it's been confirmed. But so let's see. You don't have a measurement of stationariness, and you don't have a measurement of flatness.
I mean, you just say these things like, "We've done it. Okay, move on." This is not the way to save the globe.
That's not your way of. You should come up with a different name for something other than calling it science, because that's already taken. Science is already defined, and what you're talking about is different than science. Maybe
I'm not sure if you're aware of this, right? But flat Earth has grown not because of flat Earth, but because of people like yourself who are asked for evidence, proof. You just fob them off. You say, we've done it, we've got it, it's out there. When here right now live, you should be showing your audience and the fence sitters the practical demonstrations of your claim.
Yeah, I sent it earlier, mc2.net/burden. Here's a practical demonstration. This map right here on the wall is used regularly to plot courses, international courses over between continents. Sure. It is a globe-based map. It is not a flat-based map. That is as practical as you can get. Somebody says, I need to go from here to here. How long will it take if I go this speed? How much fuel am I going to need? Let's load up that amount of fuel plus extra so that we can have some, safety margins. And let's go. Let's put a whole bunch of people, put their lives inside of an airplane. And if we're wrong, we're going to crash. But they make it.
That's nothing to do with a globe,
all the time. And that's the beauty. That is as practical as you can get. People's lives are on the line. If the distance is wrong, because when you fly from Santiago to Sydney, if the Earth is flat and the AE map is correct, and I don't know what map you might think is best, but if the AE map is correct, it's more than twice as long. They don't have enough fuel to make it. They'll crash and die, but they make it. That is as practical as it gets.
I think the next time we talk, I mean, again, I think this is not about evidence for you.
I know it's not about evidence for you. You don't like evidence.
I'm more interested in why you have this belief in the first place. I mean,
people do it.
You haven't been able to demonstrate any kind of practical demonstration. You've given me nothing more than scripture.
I did. I showed you the measurement of water curving. So, all right, let's keep moving here. We're getting close to the 2-hour mark here. Mr. Present 99 is asking, why do you do this to yourself? Talking to a wall is more productive at this point. This hurts my brain. He is a force. The force of naughty. Don't be so insulting. There you go.
I ask myself, why do globe earthers do it? I mean, it's not like you're going to be able to produce, because you're not going to produce evidence, and all you're going to do is increase the flat Earth because people are looking to you, MC2, as an authority to provide information for the globe.
Do you got a map? You don't got a map? You don't got a flat Earth?
There is a map already, isn't there?
There is no flat Earth map that's useful for international navigation.
No. Again, there's a map that can take people from where they need to go, A to B.
Skydiver Tanner says, "What's the end game? Do you want to keep arguing, Spurs? Do you still want to be arguing this at age 7?"
Again, I wanted to begin this by saying, again, it's not a debate, it's not a discussion.
Well, this is more the shape of the Earth. The Earth is physical, and its shape has been measured.
See, we
and I
don't really
have some.
argue this, like, because you're being very argumentative. I'm just asking you questions, and all we do is expose the lie.
Reject
People like
the
yourself
evidence.
cannot demonstrate your claim to be true, and all we can do is wake people up in that fashion. Because, as I said, you are seen as an authority.
Did you do that tour with Riley and them back? Was that a year ago?
Yeah, we went around and we spoke to some people, and that's what we
people
did.
met you? Did people met you?
Yes,
I've never seen you on video. Have you been on video?
Yeah, you can see me there with
Okay.
Mark Sargent, with Anthony, with Roxanne, and Jason.
Okay.
But like I said, when we go out there, we don't really argue so much more than just plant seeds and expose the globe lie.
Of course, yes. Yep. All right. So let's see. Truth Nerd says the not a force is strong with this one. These are not the droids you're looking for.
It's been fun, MC.
I like you, man. It's been good. All right, let me get through these a little more quickly here. So brave not to wear face palm protection. MC Tune says the Elmings. You know, I'm a trained professional. Bowhammer 335, who had a debate with Rad Vlad the other day, says Spurs. How does a sextant work on a flat Earth, specifically in the southern hemisphere?
I mean, again, these sextants require a horizon. You're looking at stars. Again, you're looking through the atmosphere that is magnified, acts like a lens. So your sextants do not work on your globe or on the flat Earth.
So when navigators use sextants, do they fail to?
Well, there's been shipwrecks for many years, right?
Yeah, but is it because of a failure of the sextant to figure out where they're at?
Well, what do you think?
Or was
the
it
reason
something else?
We'll never know.
Okay, so you can't suggest that the failure of a sextant is the cause of the so
again, what my point is
that if you were to use a sextant in Johannesburg, would you accurately be able to measure your latitude and longitude?
No, that's what I'm saying. It doesn't give the information, because if your information tells you you're on a globe, then it's incorrect, and it would do, because again, the atmosphere is deceiving.
Is just a yes or no? If you're in Johannesburg and you use a sextant, are you able to accurately, using what we know about navigation, celestial navigation, are you able to accurately get your position?
I would say that whoever uses these devices, they have to be aware of other factors, like I say, the atmosphere, the false horizon, and the luminaries could not be where they think they are.
Okay, but
so again, this would have to be verified.
You didn't answer my question. The answer is yes, they do accurately get their latitude and longitude.
Well, that's your opinion.
Once more, no, it's not. It's not an opinion, but that's fine. We better keep moving here. B-Ball for Life says, Spurs, have you figured out how two people looking south on flat Earth can see the same southern star rotation?
Again, this is yet to be verified. If you can get 2 or 3 observers looking at the same star at the same time and validate that, then yeah, obviously you would have something to talk about. But right now, these things have never been verified. Again, these are just part of the idea.
That's beautiful. Beautiful deflection. I love it.
And if the Earth were a ball, then you would be able to see these objects at the same time. That's the idea.
I happen to have my oh my gosh, so many. My lock screen here is actually a southern star rotation. So yeah, anyway, also on my website I have somewhere several different links to different places of southern star rotations in the southern hemisphere. It's great. So all right, Brady Photography.
What are you looking for when you speak to a flat earther? I mean, flat earthers are pretty much set in the understanding that the Earth is not a globe. That's pretty much where we are right now. Now, if you're looking for full exploration, you should know that there is a treaty which prevents people from full exploration.
There is.
people can go to certain parts of Antarctica, but we
what-
understand where you can and can't go. And if you were to try to navigate the entire Antarctica,
Okay, hold on a second. I'm going to pull it up here. What part of the treaty, because I have it on screen right now, what article and paragraph of the treaty says that you're not allowed to go there? I have it on screen right now so we can look at it.
Yeah. So it tells us that obviously you need to get the right permit.
What article says? What article says? Go ahead. I'll it's on screen right now so we can look at the specific article that you were talking about.
Yeah, like I said, well, I don't see it on your screen. It's not on your screen.
Yeah, that's fine. You just tell me the article and I'll pull it up and read it.
And is it what do you have in section 8 or 9?
Article 8 or 9. We got Article 5, 6, 7, 8. In order to facilitate the exercise of their functions under the present treaty, and without prejudice to the respective positions of the contracting parties relating to jurisdiction over all other persons in Antarctica, observers designated under paragraph 1, article 7, and scientific personal exchange under sub blah blah, members of staff accompanying shall be subject only to the jurisdiction of the contracting party of which they're nationals in respect of.
You see there, MC2, and that tells you there that you can only go with certain restrictions. You can only do so much now.
Where?
What you've just said there.
Shall be subject only to the jurisdiction of the contracting party of which they are nationals. So if you go, you're only subject to the jurisdiction of the country that you're going with.
I'll have to review it, but there are sections in that tell you, you need certain permits to explore certain regions.
And true or not, does a permit prevent you from going there? It just says
obtaining a permit to go there is very difficult.
Now, let me see. Is the word permit there? Permit maximum economy. Nope. The word permit is only in there once, and it's not the type of permit you're talking about. Maybe you should beef up on exactly what.
I'll have to definitely take a review of that.
Sure. Now,
but, like I said, we've never seen full circumnavigation, so as we understand.
Yeah, so all right. Well, let's just have this while we read. While I read a few more here. Yep. All right. Let's see. I gotta get. It's an uncut Atlas 5. So let's see. Thank you, B-Ball. Or sorry, Brady Photography. Remnant Art says, is using the toilet successfully are also part of the muddle, Spurs.
Sorry, is the what?
Is successfully using the toilet part of the muddle?
Part of the muddle. Well, some people used to tell us that the way the toilet would flush or the way the water would run down the toilet is an indicator.
That was never true, though, right? So,
of course not. No, absolutely.
Yeah. Let's see. Geistview for $5 says, Spurs, the atmosphere lens Effie argument fails because you have to be outside the lens looking through. You're not outside the lens, harder to walk up than down.
Again, yeah, I mean, these are good ideas that would help you support the glow. But again, you'd have to show practically what you're talking about is true and can be repeated.
It's been done, and I already referenced it.
I know you say that. I know you say that.
You haven't. All right, Spurs, if you take full water column.
Miracles have also been done, yes?
All right, so hold on a second. Spurs, if you take full water column and open 3 tabs on the top, middle, and bottom of the velocity of water ejected increases the lower you go. Why is this when all the water inside is the same density?
Is that in a container he's talking about?
Yeah, in a full water column.
Mm-hmm.
And you open 3 taps, not tabs, taps on the top, middle, bottom.
Yeah.
The velocity of the water ejected from the tap, right? So that's popping out the side of this water column. It increases the lower you go. But the density of the water is the same. So why would that be?
Well, you're in a container, so you've got pressure. You would have a gradient. That's normal.
But what causes that gradient?
The container.
The container causes the gradient?
Yeah, the pressure.
What's the hypothesis that confirmed that the container causes the gradient?
Well, you can't have pressure without a container, right?
That's a different topic. What's the hypothesis that you use to confirm that?
Well, can I have that gradient without the container?
That's a separate topic.
Well, could I have that pressure, without the container?
It's a separate topic. What is causing the gradient?
The container.
The container isn't causing the gradient. The container is the same top and bottom. I think you're in a...
Sorry?
You're in trouble there. All right, Minus says, at least 2 years of explaining the same thing about gravity and Spurs still doesn't get it. And if it was true about density, Spurs would be upside down.
No, that doesn't work like that.
Apparently.
We're now in disequilibrium. Change the medium. We are now in equilibrium, and there is no direction. There is no up and down.
Okay, and that causes 9.8 meters per second squared.
Nothing causes 9.8 meters per second squared.
Let me
change the medium. That rate changes.
Let me circle this one again. All right. Let's see. Kick-Ass Dave for 10 pounds says, I don't believe it's possible for anyone genuinely serious to be that intellectually dishonest. Force him to address your points and don't move on till he does. He never directly responds to anything. That's a good point. The 9.8 meters per second squared downward acceleration is measured. It's easy to confirm.
I appreciate the keyboard warriors, but let them try to sit in your seat and let's see if they're able to handle the pressure that you find yourself in.
I get what you did there and how that you didn't answer it. Okay. The NASA Black Site.
Go ahead.
We already got that. Cretan Ball for 5 Canadian says, I came into this thinking that Spurs was a Poe, but now realize he's a master of flat earth sophistry. There you go. You have convinced somebody that you are not a Poe. Congratulations.
Well, again, we do draw opinions and different views, but it really is not about us. It's not about the individual. All we do is raise awareness about the lie of the globe and plant seeds about the truth of where we live and how to conduct science. That's what we do.
No, remember, you need to rename it. It's not science, it's something else. Science is already, the definition has already been taken. You gotta come up with a different name. I mean, at least Robotham did. He came up with a different name for it. Okay.
Well, we call your science pseudoscience.
Oh, I don't care. Yeah, none of us care what you think about it. So science is used. Pick something else. That'd be cool. Anyway,
I think you're more religious than you like to think.
Some people have said, like, you could call it Rileyism, but I mean, there's more than just Riley at it.
Like, right. For example, if there was a God, you'd want to know, right?
Sure.
Most atheists want to know if there is a God. So that's what I mean. You would be more religious than the religious people who are religious. Because you want to know if there is a God, you want to know if there's more, if there's a deeper answer to all of these things.
I don't know how that has to do with anything.
You're looking for the bigger answer. Well, I'm just saying that you're lost on how you understand the world, and you're trying to demonstrate it through written documents, which means nothing.
Spurs, I don't. Do you think I'm an atheist?
No, I'm not. I didn't say yes. Most atheists. I was just thinking in general that they want to know if there's a God. Is there God like this? And they kind of doubt it because they say there's no evidence for a God. But if there was evidence, they would say, "Show me."
Okay. Certainly, they do say that a lot, don't they?
Certainly do.
So, all right. Let's see. The NASA Black Site says, contact Cypher 0 number 5739 on Discord for the sound clip. He has all the derp on Schemo. All the derp. Somebody's got your derp cataloged.
Yeah, I mean, like I say, the flat Earth kind of has a following. People are interested in knowing the truth. We obviously bring you that.
As you say, as you claim. So, all right. John Rapp says Spurs has nothing but hypocritical analysis. Hypocritical. Oh my goodness.
Hypocritical.
No, hypocritical cityness.
Okay.
Which, you're super critical about the evidence I present, and really sloppy on what you have, which is, I mean, that's par for the course.
You do know you observe the horizon is as level and flat, right?
No, I've measurements of it not being flat, but we don't have time for that right now. Maybe a second round
Sure.
if people want it. If you want a second
Sure.
round, say something in the comments. All right. Hugh Jars. You know Hugh? He's got a Hugh Jars. He says, if what's important is finding out what they're lying about, the Earth's shape, don't you first need to establish whether or not they're lying at all?
Yeah,
That's
which
true.
we have.
You're presupposing.
We've figured out.
You're presupposing flat. Swedish Vape UK says, prove that they lie about it.
Well, again, we ask questions about your truth. We find out it cannot be demonstrated, so therefore it can be nothing more than an idea.
So far, all you have is though, because the evidence I've shown you.
I've asked you to present your idea so we can test it.
MC2.net
I don't care. I'm showing you.
Yeah.
Remember?
Build your own torsion balance and see if gravity works, if mass does attract mass. If you can find that it doesn't, that'd be a breakthrough. So there you go. D Green, let's see. Oh no, Geistview is saying, ask Spurs, how many tangents does a sphere have? Well, that's a good one.
It has many as it wants to, it appears to, right?
Absolutely. That's a good answer. At least you got that right, because Bev got super confused by that.
I don't agree with this. This is nonsense. But you guys have as many as you. Again, it's an idea, so you get to make it up.
That's just geometry. It's just geometry.
You get to make it up as you go along because it's just an idea.
D Green is wondering, why does a density column mix in freefall?
Again, this is yet to be demonstrated into the right rigorous. Now remember, science is about rigorous, repetitive conditions. Now, if a guy is holding it, he could have shaken rigorous. It. Yeah, if a guy is holding it, he may have shaken it. This needs to be stabilized in a way where we can see that the mixture happened as I said it is.
So
not
all right, yeah. You want rigorous. All right, Astronomy Live says, this is a good question. I do know a little. He says, why did you remove frames from Red's video?
Okay, yet again, we've been over this many, many times. I've been on Red's rhetoric. Red is happy with who's done it. The guy who's done it has also come forward and spoke about it. All I did was discover Red's video, passed it on to the Flat Earth community, and whatever happened after that is nothing.
So I know some people think that you and Flatzoid are one and the same, but he's from South Africa and you're not, correct?
Right. So all I did was just pass it on, and then whatever happened.
So it was Flatzoid that removed the frames.
There you go. So you know the story.
Okay, there you go. All right. So there it is. Flatzoid. Why did you remove the frames? Morton Nielsen says, Captain, deflectors are overloading. She can't take it much longer. I know that was probably terrible, Scotty.
Because again, when we're asked questions, when the burden of proof is reversed, we're not the one on trial. You guys are the one who make the wild claim. And you're
like
in
I
a
said,
position where you're
mc2.net/burden. It's all there. All the burden has been for centuries has been there. But this is, a short list of it. So
okay.
That's a good question, Spurs. According to the Globe, how high is the bump in the middle of your kitchen floor on a globe, right? Say it's 3 meters wide is your puddle on the floor. Can you, using globe geometry, just the geometry to get the hypothesis, because that's the point of it, right? Can you calculate the amount of the bulge? Are you able to do that?
Oh, we're talking, is it even measurable? Because over 150 meters, you have like half an inch.
Yeah, it's pretty small, isn't it?
So what are you talking about?
So when you say that puddle is flat, you didn't include any measurements of it, and what would the measurement be, and what would the margin of error and the precision of the instrument need to be? It's very, very precise. So the resolution, like I was saying, the resolution of the instrument is high. So, all right, I got almost there. Google Vendée Globe Race. Now explain it. Vendée Globe Race. That's
Bendy, what is that?
Well, I'll Google it as who said that? Tommy Grunwald. Grunwald. The bendy globe. Accept all cookies. There you go.
So how did you hear about flat Earth in the first place?
How did I hear about flat Earth?
Yeah, so one day you didn't know that people understood it was flat, and then obviously you did. How did you come about it?
How I was listening to science lectures just on YouTube in my spare time for an interest thing, and then happened on a couple different videos. So then I went and I spent at least a year on some forums, just talking with people. I'm like, man, you guys are crazy, but it's an interesting thing. Anyway, my entrance into YouTube was just happenstance. I responded to Flat Out Hero and his challenge that I successfully completed here to do a triangle on the surface of the Earth using flight charts where each corner of the triangle was 90 degrees. So, and that's that. That is a very practical demonstration, and of course they can all be flown. So there we go.
Okay.
Let's see. Kang042 says, please explain the Uncut Atlas V video tune show. So I showed a video, I think maybe you were watching while I did that, of an uncut video of a rocket from ground out to space where it's in space and you can clearly see it's in space. What do you think about that?
Well, we know we can go as high as 60 miles. So I assume that's where they went.
It looked probably higher. Not sure. But
no, that's the limit. I think we can go maybe a little bit higher, maybe 70 miles, but around 60 miles is the limit.
Then what?
Sorry?
Then what happens? What stops people from going higher?
Well, you don't have anything to push off, right?
What do you mean push off?
Well, a rocket would need something to push off in order for it to fly.
That's not how rockets work.
Yeah, if you have
wait, do you have a disproof of Newton's third law of motion? Please present the disproof of Newton's third law of motion. I'd love that.
No, but what you don't understand is when you have a low pressure next to the exhaust or whatever's coming out of the back of the rocket, it won't be able to maneuver, and we can demonstrate that again. Yeah.
Well, you're going to have to do better than just saying it, but because Newton's third law has never been disproven to my knowledge, and so you don't need to push off of air. And
so look, let's take this is just a very crude example.
No, I'm sorry. Your standard of evidence is rigorous, so you're going to have to provide a rigorous one.
Understand the principle, then obviously we can move on. But let's just take a regular candle or a lighter or flame of some kind, and then we take the vacuum cleaner, put it next to the flame. That vacuum is not sucking, but it's creating a low pressure. Now, if you've got this low pressure next to this high pressure, the high pressure moves into the low.
So that's not how rockets work. Rockets work by expelling matter away from it. It accelerates it away from it. It doesn't push off of anything. But that's been done. You can look on YouTube. There's quite a few practical demonstrations of people doing that but that's fine. Okay. Let's see. Tommy Gronwald says my own experiments on gravitational lensing. So let me get that up. I'll put it up on screen here quick, and we can look at it. Do you know Tommy? Tommy's great.
Hey, Tommy.
Hey, if you're not subscribed to Tommy, do it right now. Tommy, pop your link in the description or in the chat there, so people can go and sub.
I mean, if anyone, if any of your listeners are struggling with getting their head around or coping with it,
I don't think they are. I think for the most part they get it. All right. Okay. So we're watching. So I'll send it to you too, so that you can You can look at atmospheric lensing practically demonstrated by Tommy. So I need to, all right, cut out the super chats, people. I need to finish this up.
You're doing well tonight.
What's that?
You're getting paid. You're doing well with the super chats, right?
Yes, thank you very much, everybody. I've got a couple things. I've got a few tabs in me, and I need to get them out of me, and they're demanding. There is a certain pressure demanding that they get out of me, and I don't want to have it be too much, if you know what I mean. It's not like I'm in 7th grade anymore. I'll tell you that tonight, maybe later. Morton Nielsen says lions. That would work fine for the new word for. Oh, there it is. Instead of science, it's lions, says Morton Nielsen. There you go. You've got a name for it now. Robotham, what did he call it? The term he coined. Remember that?
Sorry, are you reading? I'm just reading your chat here.
What did Robotham invent?
Robotham. He had some inventions, right? I think.
The non-science, the replacement. Crud, I forgot.
He's always going to get a bad rap because, like I say, he was a prominent flat earther and brought the truth to the world. And obviously, they're trying to protect the lie that is the globe. MC.
Yeah. Zeticism. See, he at least invented his own term. So I think lions is a good one. I mean, maybe you want to come up with another one. So there you go. All right. Minus says the amount of vigorous testing FLIRFs makes is equal to 0. Yeah, the rigorousness of your requirements for globe stuff is high, and the rigorousness of FLIRF stuff is 0, right?
Well, let me ask you, if something's not curved, then what is it? If a surface is not curved, what is it?
It's been measured to be curved. I showed that earlier. So, all right, let's keep moving here. Kang042 for $5 New Zealand dollars says, Spurs, are you the guy on the Calvin Harris song, I Created Disco?
I wish I was. Unfortunately, I have to burst your bubble. That was not.
I don't even know what that is.
Me either. Yeah.
Oh, well, Calvin Harris, I Created Disco.
Sorry to disappoint.
All right. There's no. I found a video, but that's not it. All right. Tommy Grunwald said, "Oh yeah, the race it's a sailing race around Antarctica, and it's going right now. That's the name of that is the Vendée Globe. So there you go. You should look into that. If the distance around Antarctica is what matches the globe, it doesn't bode well for flat Earth. So all right, Astronomy Live says I used parallax and measured the altitude of the payload after that Atlas launch. It was already 300,000 meters, I'm guessing. 300,000 kilometers from Earth just a few hours after launch. So there you go. Astronomy Live measured it was more than 60 miles. So your hypothesis that rockets have to have air to push off of doesn't work well.
Well, again, that would depend if the vacuum of space is low pressure.
Yeah, it is. Yeah, it's still pressure, but it's not zero. Yeah.
If it is low pressure, then nothing is working there like a rocket.
But except that his measurement shows that it did. So I guess it's on you to have a practical demonstration that the Atlas V rocket was not at more than 60 miles. So that's a good, maybe the next time you could have that. So, all right, Geist View. Spurs says the Earth is flat. A nautical sextant works with a nautical almanac. How does it work on a flat Earth? Not if it does. How does it work, Spurs?
I mean, it worked the same way it works right now, because what we have, you need a horizon. We can give you this apparent horizon on a flat Earth.
Okay, but that's not.
Can't give you on a flat Earth.
You're measuring the elevation to stars, then.
Yeah, but what we can't do is give you a physical geometric horizon on a flat Earth. We can give you an apparent one.
Yes, of course, but that's not the thing. How does a sextant work?
Well, they've got to
Because
line it up.
because you get the actual location. It actually works.
Well,
it really,
again,
really
that's
does
what we're
work.
told. I get. I'm
So
inclined not
so just
doubt
denial is all that you're going to come back with, right?
I don't doubt you, but again, it's going to require, to convince the fence sitter a demonstration.
Yeah. Yeah, it's been used for centuries.
I
So
know you guys
I
don't
guess
like
it's safe.
demonstrations,
Okay.
but I mean, look, if you want people to believe the idea, you're going to have to show that the idea
Yeah,
is.
and most people do. So that's awesome. The conversation about flat Earth is really just entertainment for intelligent people. You understand that, right? That's all we're doing.
I hope it is, because if it's not, it's going to be a nightmare for you guys.
So yeah, Mute Donkey says no Spurs sextants use angles would not exist on a flat Earth. It's exactly right. So Fohammer 335 says can't stop, won't stop. Like, sorry. And here's the last one. Spurs 802.3 AT. How does GPS work? Why won't FE test?
GPS works as a ground positioning stations.
Is this a claim without evidence?
Do
you have evidence of this claim?
Not right now, no. But we've located, discovered information that suggests that they're all on the ground. Yeah, absolutely.
Underground.
I didn't know I was going to be asked that question. So I wasn't prepared for that question. But yeah, for sure, we've seen information that shows its ground positioning system, not satellite.
I see. All right, here's a challenge for you if you really want to put that to the test. Get a Yagi highly directional antenna, right?
Mm-hmm.
And then go look up the GPS specification, get that antenna tuned for the correct frequency, point it up so that you cannot receive any signal from down, right? And then find where you get a signal from a satellite or not, right? And then same thing, point it down and see if you can point it down and get a signal from a ground-based system somewhere. Real simple. You don't actually have to implement the GPS specification. You just see whether or not you can get the signal or not.
No, but remember, satellites presuppose curvature.
No, I'm sorry. Just to test whether or not GPS is ground or satellite based.
Oh, that's one option. It could be a sataloon, like a balloon.
Sataloon. Right? And do you have evidence of these being moving at the rate that they need to move?
Again,
I know the answer. It's a rhetorical question. I know you don't.
Yes.
So, do you know what a Yagi antenna is?
No.
I didn't think so. It's a directional type of antenna. So,
okay.
All right.
Nice to learn something new.
We have exhausted the super chats. No more, please. I appreciate the super chats very much. And Spurs, I do thank you very much for coming on. Would you like to wrap up with some thoughts of wisdom?
Just want to say thank you for having me on. And to the listeners, to the viewers, it's going to take time to get your head around, because every flat earther took their time understanding that they've been lied to. So it doesn't happen overnight. And 9 times out of 10, you become a flat earther is because of what the globus say, not because of another flat earther. So we'll bid you farewell with that. Thank you, MC2.
All right. Thank you. Everybody else, thank you very much. I'm sorry. A lot of people sending me messages in chat, and I can't keep up with all of them. I apologize for that. And of course, yes, bendy water, a Scythe decay. I think spherical blobs of course, water bends. So, all right. Later today, I've got in an hour and a half, I have a discussion with Ian Ferguson, who is a former 5G cell phone tower installer, and he came to think that 5G was bad, so he actually changed careers. So that's in an hour and a half from now, and I have with me I have John Snow, who's gonna moderate, and I've asked him to be heavily in favor of Ian. So it's going to be a two-sided or one-sided, or I don't know, skewed it's not meant to be a debate. We want to have a discussion and productive time. So anyway, whatever you, if you liked it, give it a thumbs up. If you didn't, give it a thumbs down. And if you have a message for Spurs, maybe you want to pop it in the description or the comments here. And I'm sure Spurs will come in and answer in great detail all of your questions. Right, Spurs? Right? Nope. I don't know. Anyway, he didn't answer. I think he's left. So, all right. Thanks, everybody. We'll see you in a little bit. Bye.
Oh, we're still here. I thought you were wrapping up.
Hold on a second. I undid the end roll. Yes, I was just saying that that people might have questions for you and pop them in the discussion on here, and that you'll come in and you'll put in great detail and rigorous testing behind all of yours.
Absolutely. So are you not wrapping it up now then?
I am, yes. And so there we go. All right. Thanks, everybody. We'll see you.